complete. And then I think we are going live. There's already an echo. Are we live? Oh, sorry. No problem.
Then we are good to go. Going live in 5, 4, 3, 2.
All right. Well, welcome everyone to DappCon and to the Circles workshop. Daniel will be leading the charge, but I will give a short introduction. Presumably, most of you are already familiar with Circles. Maybe some aren't. Maybe if you already have a Circles account, or could you raise your hands? Or the inverse, okay. So everyone, I think, maybe has already, so then we already know a little bit. I will run quickly over some essentials, but because this is a workshop, also feel free to interrupt and ask questions. And it's not meant to be a talk. For a talk, Martin will speak tomorrow on Thursday, so you should definitely go there. Yeah, let's just kick it off. So as I was saying, I will just quickly go over some essentials, and then maybe the other part, getting everyone onboarded, is not necessary because we already are, but we'll do just a quick check. Also maybe with some quick tricks on how to dev experience setup. But and then I will hand it over to Daniel, who will talk about how you build your own wallet on Circles. What is Circles? So probably you already know it, but we want to say now that Circles is a social money. Many of you know Circles as Circles UBI, which is a very ambitious goal, and so by framing it as a social money, we emphasize that it's built together on this social web of trust. And so anyone can join. There's no questions asked. There's no KYC. Anyone can then also mint 1 circle per hour. But the critical part that's not easy to understand or novel to Circles as a money is that you can't just arbitrarily spend your circles. Normally, if you have $1 or €1, you go like, okay, I can spend this anywhere. But with Circles, we need to find a social path from you over your trust relations to the person you want to pay, and that can limit how much you can spend. And so that's also where then the foundation of Circles is based. Like, you might arbitrarily be able to mint as many circles as you want, but if you can't spend them, then fine, have your excessive circles balance. And so that's the root of it. And so that also is where the value of Circles is, because people will ask, if I can just mint arbitrary circles, then why does it have any value? We will go later in a little bit into sort of that it's not just an unlimited amount of circles that can exist, but there is also real value that you create when you maintain this social trust network, because especially it's more acute now and going to be in the future, we have these very real, lifelike bot systems that can talk and write text before, but now they can talk and generate video. So it's very hard on the internet to know who's an authentic human being versus some AI-generated bot. And so it will be increasingly valuable that you know that you're interacting with a real human, not with some AI bot. And so this trust graph will become an increasingly valuable data asset. And so what we actually want to convey to people is that you're doing valuable work. Because if you don't trust anyone, you might have your circles, but they're not spendable. If you just, on the internet, go trust any account you find, you might hold your circles, but you will hold them in balances of bots that are also not spendable, because they will swap your spendable tokens out with their bot account balances. And so the analogy is a little bit like water. Like, if you don't trust enough, your water is frozen and it's not moving anywhere. But if you just carelessly go around trusting accounts, then it's like a gaseous state, and it will just fly out of your wallet. It's also not usable. But if you just go trust the people that you actually know, that you keep in touch with. Also, if you fall out of contact with people, you should prune your trust relations. In this liquid state, your money is actually liquid, right? And so that then also creates a social graph. And so just very quickly, what that means is that because this is a workshop, we want to go a little bit more in depth. So what that means is that we need to find paths between Alice and Bob. And so that also requires that we will see this in the demo, that you need to go, you can't just sign a transaction that Alice needs to send 5 circles to Bob. You need to sign a transaction over which path Alice sends those 5 circles to Bob. And to go a little bit more in detail, so imagine that these other intermediary nodes are other people that each have a trust relation with each other. Then what a path transfer is that Alice actually gives 5 circles to her friend. Then that friend under the hood moves those 5 circles forward to their friend, and ultimately we reach Bob. And so that's something that we need to account for in the architecture and also solve for. Maybe if you have questions, like happy to go into details, also like what we're doing now and in the future. Yeah.
Yeah, maybe you mentioned that there is this trust connection.
Right.
It's supposed to prevent bots from joining, which is not trust of bot, for example, but
Right.
it seems like there only needs one person who trusts its army of bots. So they don't just kind of see attack or...
So for the recording also, I'll quickly repeat. So, and for myself, so you're saying that if one person would trust a bot, then doesn't that now harm the whole network? And so you can think of these edges between the people having a certain capacity, and it will dry out. So say that Alice trusts a bot account. Then now this bot can pay Bob over Alice. And so say that Alice has 100 circles. For the amount of 100 circles, this bot can actually buy something from Bob. But Bob still just receives circles from people that were honest, and so for him it's fine. The only one person that actually loses the damage here is Alice, because she had 100 Alice circles that she could spend to Bob, but now she has 100 bot circles that she can't spend anywhere. Well, to the bot, but like... So she loses the spendability of her 100 circles because she indeed trusted this bot, and so she's the one impacted. But also, it's limited to that 100 circles, because now she doesn't have any circles anymore, and the bot also cannot buy more from Bob. So there is a natural capacity that drains out in the system. Other questions? I don't have so many slides, so we'll go very quickly over this. The other aspect maybe is coming back to this, every person receives 1 circle per hour, no questions asked. So like, that's roughly 8,700 something circles per year. If everyone just does this, doesn't it keep increasing the amount of circles that there are in the world? And so there is actually a balance to this that we don't often talk about, because it gets more difficult to talk about, and so we want to refine these stories. But there is a temporal discounting or demurrage of 7% per year. So you could think of it as a tax of 7% of the circles you have per year. But you now have these two, and so normally, like, this sounds bad, right? Like, oh, 7% of my value gets taxed or disappears. We don't like this, but it's very different from when we have this with euros or dollars, which also inflated, but the inflation happens in the central bank. Like, your bank account doesn't get minted new dollars when the central bank mints new dollars. They mint it for them, but you lose the 7% on dollars or euros. But here, you lose the 7% on circles, but you also get the new circles in your own account, which is a very different dynamic to start with. And if you then take those two terms out, you actually get, as an illustration, this curve. They max out, or they balance each other rather, around 125,000 circles. Because if you have no circles, then 7% of 0 is 0. But at 125,000, 7% is this 8,700 circles that you get per year. So then you have a natural balance point. And so if you start minting your circles, then you will increase, first sort of get those 8,700, but as you have more, you pay more 7% tax, so it actually starts flattening out, and you have this balance point. If you then stop minting circles, you only have the 7%, so it will go down as in the second part of this curve. But what this really means, and what I think is a really interesting story, is that it's effectively a more honest distribution system. Because if you're a human, you get negatively taxed until you have under 25,000 circles, because you have this constant mint that happens, and so the less money you have, the more you receive. And then up to this balance point. And then if you earn circles because you're active within the community, you will slightly get taxed more. But yeah.
But if I send out my circles to another wallet, will they also be taxed?
Yes, like because it's part of the protocol, so it doesn't matter where you. Yeah. There's no escaping this taxation system. But also for like AIs or bots or companies, they can earn circles, but they don't have a mint because we wouldn't trust them to as a human. We would go like, no, I know you're a bot. I know that. I mean, in a one-to-one relation, and so they have a flat tax of 7%. So humans get this negative tax, but companies and bots get a flat tax of 7%.
It also happen if I bridge it out from Gnosis chain.
So. I mean, it's a workshop, so let's go a little bit more in depth, right? So there's two ways that you can implement this, with an on-chain demurrage or with an inflationary model. So typically, dollars or euros, we have an inflationary model because you have the same amount of euros in your bank account tomorrow, but they're just like in the central bank printed more euros, so your actual purchasing power of your euros went down. Right? That's the inflationary model. The demurrage model is where we rebalance, we readjust all the numbers everywhere to actually go down, and so your purchasing power is more stable, which is the default model we have here. If you'd want to bridge it over, you would want to use circles in the form of the inflationary unit, and then the answer is still the same. The only way you could bridge it over sensibly is in this inflationary representation, and then you will move 5 circles over, but they will be less because the total amount has grown on the Gnosis chain as well. So yeah, you will still have exactly the same 7% effect. So when you come back with those, say, 5 circles that you bridged out, you will find that they are now worth less in the original system. Yeah, sorry. So anyway, yeah, so this also just answers this question. Like Bitcoin originally was very utopian, and it was a nice story back in the day for having a hard currency that wasn't debasable. But now we have roughly 21 million Bitcoin in the world, and we also know who has those 21 million Bitcoin. Like, it's definitely not me. And so I'm not very motivated to build a system on Bitcoin because I'm not, I mean, yeah, well, let's leave it there. Whereas here, like, there's a more sensible long-term dynamics to the system. It doesn't matter when you join circles. It doesn't matter whether you were there long. You just, I don't know if I can go back one slide.
Can do that.
Yeah, it doesn't. This curve starts at an arbitrary point. It doesn't matter if you are born 3 generations in the future. You have the same dynamics, and there's not like a wealthy older class that already just has all the coins because they keep rebalancing over time. Oh, now I moved in reverse. I click reverse. Anyway, I'm at the end of my slides, I think, already. So I do want to acknowledge we started as a small team more recently, and will propose some both on the technical side, but also try to help move forward the story and invite more people to build on circles. And that's really something that we want to enable, is like, how do we also have more digital services being built on circles, not just real life vendors, but also build it into our protocols. But having said that, we really want to see ourselves as ambassadors, because there's many groups, and actively actually many different groups around the world. We keep discovering them by chance, of people that have engaged and are engaging with these ideas and want to help build them forward. So if you have your own ideas, it's a very open space. Happy to collaborate or independently work on things, or just to move this vision forward. I don't know if I had more slides. No, I did not. So I don't know if people have questions maybe first. And then second question would be, does anyone not have a Circles account set up? And then do people have a laptop or something ready? Because in the coming section, we'll try to code a little bit together, or at least go through how you could go about it. Okay, I'm asking the questions too fast. Does everyone have a Circles account set up? Yeah, it's okay. This is just to make sure that we don't have people leave here without having a Circles account. This is disconnected from. This is just pure me trying to be a good marketer and having sign up. But so if you have questions on setting it up or need trust connections, this is obviously a place where you can ask them. But then I'll hand it over to Daniel. And so maybe before I do that, if you scan this, am I right about this URL? Is that public now?
Yeah, it is.
Okay, yeah. So if you scan this QR code, then or just go to the URL if you prefer typing, then that's a GitHub repository that has a whole code of where we want to get to in it. So if you miss steps, you can find it there. But we'll try to go through it step by step together, and then we'll see how far we get. Yeah, that's me. Yeah.
Cool. So I will take over the next section of the workshop, and we will do some hands-on coding. Yeah, I will give you a little bit of time to all arrive at this URL. I have to go there myself. It's github.com about circles, and then here in the repository list, it's the first entry, Circles Code Quest. And our objective for the workshop is to build a simple Circles wallet. Circles needs much more integrations in other products, web shops, and whatnot. And we're currently building an SDK to allow people to easily integrate Circles into their own software. And I will give you a brief tour of the SDK so far in this workshop. So we have some prerequisites. We will have MetaMask installed in the browser. You will need Node.js and NPM. And since the application will be built with Svelte, a Svelte plugin for your IDE or code editor, I think is a really nice to have. Further, you will need some XDAI, because we will not use a relayer and pay for the transactions ourselves. So there's a faucet for Gnosis chain. If that doesn't work for any reason, I set up a pad where you can add your wallet address, and that might take a while, but I would send you a small amount of XDAI just to get started. Maybe anyone who doesn't have any XDAI yet, raise their hands so that I know how many people. Okay, there's already one. It's one, okay. So for you in the README of the repository, I added a link to the pad. Just add your MetaMask address there, and then I will send you some. Okay, so give you a little bit of time to make sure that you have the prerequisites set up. Yeah. Oh, sure. So yeah, how do we start? I already created a UI mockup and linked the routes with each other so that we can click through the single routes and get a feeling of what we are going to build. I also have a finished finished application here. It all starts from the homepage. It's just a welcome screen to get started. Then we can connect our MetaMask, and once we did that, we see our wallet address, our current circles balance, a transaction list, have the possibility to mint our personal circles, which is basically our 1 circle per hour. We will have a screen to send circles, a list of our trust connections, because circles is all about trust, and a small settings screen that just shows our circuits address and our personal token address. To get started, I will ask you to check out the Circles CodeQuest repository. There are 9 branches within. We will start with the Create UI Mockup branch. So once you have cloned the repository, please check out the corresponding branch. I hope this is large enough. Okay, so once you're in the branch, we need to run npm install, and after that we can run npm run dev and bring up the browser with the bare bones application. So that's already clickable, but it doesn't contain any logic. As you can see, everything here is empty, and we're going to implement the single features now step by step. So maybe a short introduction about into the repository contents. Oh yeah.
Also, is everyone up to date, like with the account and cloning the repository?
Looks good. So for those who are not familiar with SvelteKit, a really brief introduction on how the routing works. So the routing is folder-based. We have this routes folder, and basically any subfolder I connect in this I add to this will form a route. So to access the dashboard, I just go to /dashboard, and we will be at the dashboard route. So there is a layout with just an. Oh, I have to increase the size. Okay. So there's a header when we are not signed in. It's a default header that just shows the Circles logo. Once we are signed in, we want to show the avatar info, which we've seen previously, which contains the Circles address and the balance. And then here's a slot where the main page will be inserted. So we start with the start page. It only contains a button that brings us to the Connect Wallet page. So if we want to switch pages in SvelteKit, we can use this go-to function and just specify the route as an argument. Let's see if that works. Going to the home page, click Get Started, and we will get to the Connect Wallet page. So far we haven't implemented anything. Next step is to add and initialize the Circles SDK. So we are going to the package.json and we'll add that here. It's add Circles SDK, so that's the NPM organization, and we want to include the SDK package. Current version is 0.043. My IDE will install that. Okay, so now that's installed. Everybody installed the dependencies already? Give a minute. So after installing the dependencies, we should restart our development server. Go back to the page and verify that everything is still working. Looks good. Okay. So now we need to initialize the SDK, and we want to do that on the Connect Wallet page where we connect our MetaMask account. Yeah, so I already prepared some Svelte stores. Svelte stores, for those who don't know it, are like global variables. So we will put an SDK instance into a global variable, just that we have it on every page. And once we connected the wallet, we will also put the wallet provider on a global object so that we can access it from the other pages. Let's change the type or just remove it. So on the Connect Wallet page, there is already some code that will connect to the window Ethereum object, which is MetaMask in my case. Once we have that, we get the signer from the wallet browser provider and assign it to this global variable. And after that, with the signer, we want to initialize the Circles SDK. So I have a template method here that needs to be implemented. And we just import the SDK from the Circles package. And immediately have an error. Oh yeah. Okay. So once we have the import, we can just create a new instance, just by creating new, and we see that it requires a chain config, so we need to configure the Circles SDK because maybe we want to run it on Chiado, the Gnosis test chain, or on a local chain. In this case, we want to go for Gnosis mainnet. So let's see if I already have settings. No. Okay. So what it will need is a Circles RPC URL. That's basically just a JSON RPC endpoint, but with a Circles plugin installed so that we can access the transaction history, trust relations, and whatnot. And we have such a thing installed at rpc.helsinki.aboutcircles.com. The next step is we will need the hub address. Let's Google that. Yeah, that's the right one. And another service that we will need later is the Pathfinder. So the Pathfinder finds the trust path through the trust graph and allows us to do transactions. We installed one at Pathfinder aboutcircles.com. And the rest is not relevant for now, but we just set a value to make TypeScript happy. And then the second argument is the signer we just got from MetaMask, and which we stored to the global wallet variable. Oh yeah, it shouldn't be null. So, okay. Yeah, once we initialize the SDK, we can just return it and see how it's used. So let's go back to the start page. Oh, an error. Ethereum is a comma. Oh. Where's that? Interesting. Okay. So if we check our MetaMask, I was already connected. That's why it didn't pop up on your side. If you connect for the first time, MetaMask should pop up, and yeah, you have to enter your password, and then we have this fav icon here to indicate that we connected actually to the application. Are there any questions so far or any problems? No? Okay, then I...
If you're running behind, like me, which branch are we?
Right now we are working on the add and initialize circles SDK branch. So if you want to skip ahead, you can just check out that branch directly. So that's that one. And I also added a link to the diff so that you can follow along what changed between the steps.
So the branch is the complete thing?
The branch is the complete thing. Yeah, so we are currently in create UI mockup and are working on add and initialize circuits SDK. Okay, actually, we finished that step more or less. There's only one thing to do. Since it could happen that our wallet was already signed up or is already signed up at Circles, we don't want to bring the user to the sign up page if the user is already signed up. So we have to add one check to see if the connected wallet is actually already a Circles wallet. And since we added the SDK instance here to the Circles global variable, I can just use that to check if the avatar exists. Oh, it's the wrong type. Yeah, we have to replace the mock type that was in the store with the actual SDK. So we get rid of the type error. And yeah, so this is the first time we have a look at the SDK object itself that has some properties. Currently we are interested in the data because we want to query for an address if that address is already signed up. So we access the data property and call get avatar info, pass in the address, and store the result in a variable. Let's call it avatar info. That's an async function, needs to be awaited. And once we have the avatar info, we can be sure, okay, there's already an avatar signed up because get avatar info will return undefined if it can't find the avatar. So with this to-do out of the way, let's see if that works. So the effect we are expecting here is if the avatar is already initialized, then we go to the dashboard, and if it's not, we go to the register page. Let's see if that works. I have my account already registered here, at least with that one, so I would expect to get to the dashboard page, which looks like it works. Now we can also test the opposite case. I just create a new account and use that. That's not connected. Interesting. We still got to the dashboard. Which is not expected. Okay. We have some time to debug. Oh, maybe it's working, and that's already registered. No. Let's try a new one. Oh, interesting. So I hope you have some time to catch up while I'm debugging. So actually, is that the address? No. Okay, FE. Yeah, that's the right one. Okay, in this case, I would expect a response that I'm actually signed up, which I'm not getting. So this is not correct. Oh. Yeah, I think that's the issue. We return undefined, and I did a type safe check for null. Yeah, okay. So, yeah, with that out of the way, we can go back to our page and add the last line of code for this step. So if we already have the avatar, then we want to add that to our global variable. Yeah, that we need to use the next SDK function, which is actually, if we already have an avatar, there's a get avatar function where we can supply the wallet address, and it will return an avatar instance. If we don't have an avatar, we will go to the register page where we will create a new one. So that's it for that step. I will go and check out the same branch as you guys have. Actually, I can do it here. So, okay. Let's go back. So everything's implemented, and continue with the register page. So here on the register page, we only have one thing to do. We need to sign up a new avatar at Circles with the connected wallet. In Circles, there are two different account types. Today, we will only care about the personal Circles account. As Ben mentioned before, there are also organization accounts which are intended for companies or whatnot. Today, we are going with a personal account. So in order to create a new avatar, we have to access our Circles SDK, again on our global variable. And instead of get avatar for an existing one, we call register human. The other option would be register organization. Both return a so-called avatar interface, and they behave more or less the same, with the difference that an organization cannot mint personal tokens while a human can. It's an async method, so we have to await it. And let's try that. So here you will need some XDAI on your wallet. So if you don't have any yet, you should transfer that now. I will just send 10 XDAI cents. And also have a look here. So Okay. Let's wait a bit until all the transactions went through. Okay, and with our account now funded, let's switch back to the right one. 29. Yeah, so 10 cents on this account. With the account now funded, I should be able to register as a person. Oh, there's an error. Wallet is not connected. Yeah, we always have to start from the front page. And let's try it now. Okay, MetaMask opens, get a signing request, send us sign up to the hub contract. And that's the right account, so let's do that. Okay, the transaction is confirmed, and yeah, so that worked, or at least seemed like. We now have an avatar instance created by Register Human, and after that we are going straight to the dashboard where we will in the next step implement a transaction list because personal tokens, personal accounts get a sign-up bonus. So we will immediately see one transaction after sign-up. Let's see if we get this to show up. The next branch is register at Circles. Or actually it's, yeah. Check out. Okay. So we move on to the dashboard page where we want to show first our current balance, not the transaction list, of course. So yeah, here in the header we have currently a balance shown of 0 circles, which doesn't seem to be right. Let's fix that first. The header is in lib components and we have an account info header. Yeah, so here are just 2 hard-coded properties that need to be set. We should by now have our global avatar instance, which we got from the register page. So it's stored on this avatar store, and we hope that we can utilize it here to get the actual balance of our avatar. First we have to remove the mock interface and replace it with the real one. So that's in the avatar store. Now we get the right fields. And we want to get the total balance of that avatar. And so we can just call the get total balance method. Actually, that's a promise. So yeah, Svelte has this nice syntax for variables that auto-update. They just are introduced with the $sign, and we will use that one. So what this does is the balance variable will be updated whenever the avatar is updated. So initially we don't have an avatar. After sign up or registering, we have one. So this variable will be set, and in turn the get total balance method will be called on that avatar instance. Let's do the same for the address. Okay, and since this is a promise, we have to await the promise here. Svelte also has some nice helpers to do that. We say await balance. While we are waiting it, we say, balance is loading. And then once we have the balance, we show it. We don't care about errors right now, so let's keep it like that. Okay, so what we have now is our promise from the avatar. We await it here in our template, show a loading message. Once we have the balance, we show it. So we would expect that to work now. Let's start again from the start page. Connect our wallet. And actually, now we can see the balance of our avatar and the avatar address. The avatar address matches the one in MetaMask. Yep. Okay, that's a first step. Yeah, now we want to show the transaction history, now that we have the balance. And let's check out that state. And go back to the dashboard page where we will implement getting the transaction list. So very much like with the balance, we get our transaction list from the avatar again. And there's a method called get transaction history. This is meant to be paginated, so it expects us to set a page size. We just go with 25 for now and don't implement the pagination, just show the first page. Okay. So yeah, it will return a circles query. Let's call it transaction history. Okay. So the query is already executed once we get it from the get transaction history call, so we can just show the current page. If we would have multiple pages, we can just call query next page, and then the current page would have the contents of the next page. We, for this example, just display the first page. And to do that, we just assign the rows from the current page to our rows array here. There we have a type issue. Let's remove that. Copy undefined. Okay, and that also should be typed to actual result type, which is a transaction history row. Oh, okay. In the meantime, our package has changed. We initially only added the Circles SDK package, but there are more. So we have the Circles SDK data package where all the row types are in, and there are the utilities where we come to later. So please, if you checked out the branch, run npm install again to also fetch the missing 2 packages. Once we have that, we should be able to import it here. Yeah. Okay. That's weird. Okay, I see what I'm missing. Language tag, it thought it's JavaScript, but it's TypeScript. Now it compiles. So if we've done everything correctly, we should get our first 25 transactions. Actually, the newly created account will only have one so far. Let's start our app again. Connect the wallet. And we see our first transaction, which is the so-called sign-up bonus. Directly after registering a human avatar, the Circles Hub will pay out, in this case, 117 circles as a sign-up bonus. And this is what's displayed here. So cool, now we have the balance and the transaction history displayed. I think it's nice to add more transactions to it. One easy way to do that would be to do another personal token minting, which is currently not implemented and which we will just do in the next step. So please check out the show transaction history branch to get to the same state. Any questions so far, or is anyone lagging behind? Okay, fine. Okay. Yeah.
Why 117?
117. Why 117 sign-up bonus? Yeah, we will come to that point a little later when we invoke the Pathfinder. There's a little history of circles and time circles. So circles started out as an inflationary unit. Just as Ben explained previously, we have this demurrage representation where basically your balance loses value over time, and we have this inflationary representation where the total supply is raised and your balance stays the same. So circles started out in the inflationary system, and then at one point we decided to make it a demurrage-based system. So actually how the demurrage is implemented in Circles v1 is just, it's a display method. So we calculate the demurraged value based on the current time, and we do that in the SDK or in the front end. Basically, it's not on-chain demurrage. With the next version of Circles, the default mode will be on-chain demurrage, and your balance will really demurrage on-chain. And there is an inflationary wrapper token if you, for instance, want to add your tokens to a liquidity pool or whatnot, and that can't handle the demurrage, then you can wrap your token to an inflationary token and use that. But for version 1 of Circles, everything is inflationary, and the demurrage is just a display option. So that's why the factor currently yields 150 circles, which was originally 50 inflationary circles. So that's why it's not a round number. Okay, so let's implement minting personal tokens. That will be a very quick step. We go back to the dashboard page where we have the mint button. You can see here mint circles and a to-do mint to personal circles. So again, we can just access our global avatar object, and it already gives me the completion, and call personal mint. This is, of course, also async, so we need to await it. And yeah, let's give it a try. Okay, we get a signing request. Transaction confirmed. So since we haven't implemented any update logic for our UI yet, we have to switch the page one time to see the new transaction. And as we can see, new tokens have been minted to our account. So that's already pretty good. We verified that our transaction list is working. We can mint personal circles, of which we get 1 per hour. So looks like a few minutes have passed since our account creation. If that would be 1 hour, we would have exactly 1 token here. Now it's 0.21. Yeah, with the minting in place, we should go to our next point, which is adding trust. So circles cannot be transferred without any trust relations. So we need a way to trust other people and for other people to trust us, and obviously also a way to show who we are trusting and who is trusting us. Let's check out the Mint Personal Tokens branch to get on the same page and start implementing the trust part. Yeah, we have that on the contacts page. And since we don't have any trust relations right now, this is a new account, maybe we should first implement adding trust to other people. So we have a sub route, contacts add, and in this page there's a trust method which we want to implement. Maybe let's have a look at the form first. If we click here, add trust, we are expected to add another circles address, and then we just hit the trust button and see what happens. So we are using our global avatar object again, and this time the trust method. And we already used the Svelte binding from this input element to the trust address variable. We also have a small validation logic using ESAS.js, checking if the address is actually an address, and that will set the trust address is valid variable, which in turn enables and disables our button. So currently it's disabled. If we would going to trust ourselves, we see it's enabled. Yeah, async method again. We want to trust the trust address, needs to await that too. And once our trust call was successful, we are going back to the contacts page. So now we need a different address to trust. I will trust my other Circles Garden wallet. You could trust your wallet or basically any other wallet. Okay, let's see if that works. Okay, I think we successfully added a trust relation. Now, page still empty, we need to show it. So let's move back to the contacts page and find the onMount function and yeah, implement getting the trust lists. So just as before in the dashboard, we have a list here and the list has rows. And on loading of the page, we just add the result to the rows. So let's do the same here, but for the trust relation. Use our global avatar and ask it for the trust relations. So this will give us all trust relations of the avatar. Trust relations can be incoming, outgoing, or mutually trusting. Let's see how that looks like in the result. Oh. Didn't await it. That's not a page result. It will just give us a list. So yeah, and I also had this mock type here, which we need to remove in order to import the correct one.
Can you, in the stores, in your stores file, can you quickly show what's there? Because
For the avatar?
there does need to be more code here in the store.
Okay, yeah, maybe a quick look at the stores, which are the global variables. So we have this avatar, which we are initializing in Connect Wallet or on sign up. Then we have the balance, which we used in the header and are initializing yeah, in the header. Circuits is the instance of the Circuits SDK, and we have wallet, which contains just our signer. So that's an ESA signer. Circuits contains our Circuits SDK instance. Avatar contains the avatar interface, which okay. Okay, I think we have another type issue here. Let's cast that empty array to some trust relation rows. Okay. Okay, with the loading of the trust relations in place, we should see something. And indeed, we are just not what we were expecting. And the issue is we're using the wrong row template. So we're still using the transaction row for trust relation. So it has wrong properties. Let's change that. Contact row. And see if that works. Yeah, that looks better. So we have this arrow, which signifies that that's an outgoing trust. We see who we are trusting and when that happened. As you can see, we have some quick action buttons. One should remove the trust relation if we don't want to trust this person anymore. And another one will bring us to the transfer page in case we want to send some circuits to that person. Let's check if the trust removal works. No, it doesn't. So we need to implement that next. For that, we go to the contact row because these buttons are defined here. Here we supply the row that should import the right type. Import the row which contains a subject avatar, which is basically me, an object avatar, which is the other avatar, and then the relation between the two, which can be I'm trusting that other avatar, that other avatar is trusting me. We are mutually trusted, and self-trust is a special case. Let's continue with removing the trust, because that's the button we can see right now here. In order to remove a trust relation, we again go to our avatar and not call remove trust, but untrust. And then we need to specify who we want to untrust. So in this case, this is the avatar we were showing in the list item. This is an async function. Again, we need to await it. So let's see if it works. Okay, so we need to change the page just to reload it, and we see our trust relation is gone. Let's check that in our wallet here. Okay, let's try the opposite direction. We previously trusted from this wallet to this wallet, and now I want to change the direction and trust from my Circles Garden account to my newly created wallet and see if it shows up. That might take a while. Actually, there it is. So this time the direction of the arrow changed, signifying that this is an incoming trust relation. We have a different button here this time, because previously we added a trust relation to the other party, so we were able to remove it. In this case, they trusted us, so we should be able to trust this person back. This is not yet implemented. Let's go back to the contact row to do that. And again, use our avatar object And this time, instead of untrusting, we are trusting that object avatar in our row. Let's see if that works. Okay. We have to reload the page. So now we can see we have a mutual trust relation. And that should be also shown in Circuits Garden, yeah. Cool, so now that we have mutual trust relations, we have a target where we can actually send to. This is not yet implemented, but this will be the next and final step in the wallet implementation. So in order to follow along, please check out the show and add trust branch. Okay. So yeah, next is implementing the transfer. Transfer is interesting. It's the point where the pathfinder comes into play because we need to find a route to our destination. So in order to implement it, let's switch to the transfer page or send page, how I called it. Okay, and here at this position, we want to invoke the pathfinder to find a path for the maximum transferable amount. Depending on your trust relations, it might happen that you cannot always send the full amount. So in this case, we have 117 circles, but depending on our trust network and the distance to our recipient, it could happen that our capacity is limited. So what we need to do before sending the transaction is to notify the user about the maximum amount that he can send. And
Even if it's a direct trust relation,
in a direct trust relation, usually it should be that the recipient can receive all your tokens. But actually, there are some limitations hard-coded in the contract, which are by some considered as a bug, by others as a feature, which limit your capacity based on your own balance. So in the current implementation, it could happen that if you run out of your own tokens, you might not be able to receive new tokens. This is a known bug, and we need to work around it a little bit. But yeah, your capacity of CSC that you can receive depends on your own balance and also on the trust limit that you can set when you establish a trust relation. So we established our trust relation, or the SDK establishes the trust relation by default with 100%. But older wallet implementations by default used only 50%, which also limits the flow between the different accounts. So in version 2, we got rid of that trust percentage and replaced it with a binary trust relation. So you either trust or you not trust. And also it's not balance dependent anymore, but this will be for version 2. Right now we have to live with the trust limitations. It's a limit per edge, basically. So between two different accounts or multiple accounts, on each edge is an individual limit, which is based on your current balance and the trust limit. But we will see how much we can transfer just in a moment. I think here in this case, since we trusted 100% and both accounts have a balance, we should be able to send the full amount. Let's see. Move back to the transfer page. And we check out our avatar object. where we find a get max transferable amount method. We need to specify where we want to send to. In this case, it's the recipient. And this will return a promise. So we need to await the promise here in Svelte again, show loading texts, and yeah, format the amount just with 2 decimal places. Yeah, let's check if that worked. And it looks like it does. So now we see, maybe let's go back to our trust relations and try that again. So now we see this is loading and internally invoking the Pathfinder. And we now get a max amount that we can send of 50.09 circles, which is a bit suspicious because I think here the time circles component comes into play. So the Pathfinder by default returns the inflationary value. And if we remember that our initial transaction here is actually 50 circles in inflationary values and 117 in the Mirage values, it is very likely that we show the inflationary value here. And this will happen sometimes because the inflationary values are the values that are stored on-chain, and whenever you do an RPC call or get that from an indexer, you will need to convert that to time circles in order to show it to a user, because else users will be very confused about the differing balances, for instance, that they can see in the Circuits Garden app versus your app. So we need to convert this value into time circuits. And there should be a method to do so in the SDK. It's called CRC to TC, which stands for circuits to time circuits. We need to import that. It's from the utils package. And since time circuits are a time-dependent unit, we will need to supply the current timestamp, which we do as a date object. And then we want to add the max amount, which in this case is not a promise. Okay. Big int. Yeah, we need to do some parsing foo. Because the max amount that we are getting is in inflationary units in Y, and we want to display that as a decimal value, so we use Ether's format Ether method to convert Y to Ether. Then this method, oh, actually we don't need that. Sorry, I changed the SDK last minute. Let's just pass in the big int. Okay, nice. Could be undefined. Okay, then let's go with a default. Okay, we need to connect the wallet again. Go to our contacts, press send, and now we can see the value is actually our balance. So we are able to send our whole balance to that user because we have this mutual trust relation with 100% and both accounts are funded. Let's go with 10. And okay, we haven't implemented the send functionality yet. Let's do that. There's an issue. Okay, to send circuits from A to B, we also go to our avatar object and call the transfer method. We need to specify where we want to transfer to, which is the recipient, and we also need to pass in a value, which is also again in inflationary units. So our value string, will need to be converted to time circuits, from time circuits to inflationary circuits, where we have a helper method, CRC to TC, which also takes the current date and this value as a number as far as I know. Oh, that's the wrong. We need to use TC to CRC, sorry. And that expects a number. And since we have a text, we have to pass that first. I think method, await. Okay, so let's recap. We call the transfer function on the avatar, supply the recipient. Since we are working in the front end with the time circuits units and display them everywhere, we also expect the user to enter time circuits. So we need to convert the time circuits to inflationary circuits because that's what's used on chain. Therefore, we pass our string to a float, supply it there, and then we get back our inflationary units. Let's see if that worked. We should be able to send 10 circles. Confirm. And let's see if that arrives here. Okay, let's reload. Oh yeah, okay, we got our 10 circuits and we should also be able to send them back. Let's try that. Send our 10 circuits back. Oh. Interesting. That doesn't work. Okay. Let's see in our transaction history if it's actually shown. Yeah. Okay. We see our personal mints and 10 circuits sent out to this address. Actually, I want to receive some now. Yeah. In order to receive circuits. I need to trust the other account, so in that case I did that, but let's try a different account. Maybe my real personal circuits account, who's now trusting my fake account. Oh. We discover some issues. As you noticed, we don't have a username or a profile picture in our wallet application. This is because currently there's only one database in Circuits Garden which actually manages the user accounts, and that's not available via the SDK right now, so we are just going with the addresses here. Yeah, unfortunately that doesn't seem to work like expected, but at least we can send from our wallet to other accounts. That works and is actually the last step in our implementation. So we can continue a little bit with auto-updating the UI. Maybe we do that because it's not a nice UX if we need to reload the page whenever we do a transaction. And it also displays a few features of the SDK regarding event handling. So maybe let's start with the trust relations. But first, any questions so far? So to recap, we initialized the Circuits SDK, registered a new account, showed a balance and transaction history. We minted personal tokens. We allowed to add and display trust relations and we calculated a transfer path and transferred circles from A to B. Are there any questions at that point? No, okay. Yeah, then let's have another look into the event handling of the SDK. So the goal for that is, if we remove this trust relation here, for instance, we want to auto-update our UI to reflect that change. And to do that, we need to listen to the events that are emitted by the Circles Hub contract. And the SDK provides a few methods to do so. So let's go to the trust page or contacts and subscribe in on-mount to the necessary events. So actually our avatar has an events property, and that contains an observable which we can subscribe to. And it will yield events, avatar events to be precise. And now the idea is whenever we receive an event, we want to update our UI. So an avatar event can have multiple types. In this case, we are looking for trust events. So these are the same names that the smart contract uses. So you can look them up in either the code or in Block Scout. Right now I'm doing this out of my head. I know it's the trust event, so I just filter for trust events. And what we want to do if we receive a trust event is we want to update the UI. Let's see if that worked. So we would now expect, after establishing trust, that the icon changes and signifies that we now have a mutual trust relation. And that worked. And yeah, maybe we want the same for the transaction list, and that should be actually the last step of our journey. Let's go to the dashboard, add the same logic here. Here we are looking for multiple events. One is called transfer, and it's the personal minting. Or it could be a hub transfer event, which is a person-to-person transfer. And we want to refresh the transaction history in that case, so we just copy and paste that code here and see if it works by minting. Okay, that worked. A little time has passed, so we got some new UBI, and that's it for the workshop. So I think you've seen the basic functionality of Circles wrapped in the SDK. Please note that the SDK is still a preview and subject to change. So if you plan to do substantial work with Circles and need a more stable SDK, you either need to wait for the official release or just approach me or anyone else from the team to get in touch and talk about how to handle your needs. And other than that, that's it for now. I hope I could show you how to integrate Circles into your applications, and we hope to see shop integrations and further wallets soon. Thank you very much. Any questions? Sure.
This SDK will work also with the Circles
Yeah, the question was if the SDK will also work with Circles 2.0, which is the upcoming Circles version, which is near completion. Yes, so there will be an update to the SDK, and the interface will remain largely the same. So there will be some minor differences. For instance, Circles v2 adds a new account type, which is the group type, additionally to the personal and organization account. So these will be added. But minting, transferring, and all the other stuff will stay the same interface-wise. So also there will be a migration method to migrate your V1 accounts to V2. So everything you start building with the V1 SDK right now will continue to work with minor modifications also with the V2 contracts.
Noob question. Obviously, all that you showed us is happening on Gnosis.
Yeah, it's everything on Gnosis chain. So we can configure it to use other chains, but since the deployment of the Circles contracts is on Gnosis chain, it doesn't make too much sense to use other chains, other than for testing reasons. So, for instance, while developing the SDK, I used the local Ganache chain. And then you can, I don't know if the screen is still shared, but yeah, you can basically specify other contract addresses and other RPC endpoints for the SDK. But usually, in most cases, you would just stick to Gnosis. Oh, here it is again. So let's go back to the configuration. That was in Connect Wallet. Or was it? Here. In this thing, it's yeah, in an object. So yeah, you have this chain config object, and you can specify different Pathfinder instances, RPC URLs, and also the contract addresses. But this is mainly meant for local testing on a local chain.
And is there any hope that we see Circles, for example, on CoinMarketCap, to actually see the token?
The Circles token itself, since it's a personalized token and everybody can create their own, it's not really listable on DEXs or anywhere else. But there will be group currencies in the upcoming version. So how these work is people can use their personal tokens as a collateral and mint group tokens in exchange for that. So if I deposit one token at a group contact, I can get one group token in exchange. And these tokens, since they just have one address and can group multiple persons, can very well be listed on DEXs, etc. So I hope we will see quite some tokens emerging via the new group feature.
But what's an example of a group token?
This could, for instance, here in Berlin are many alternative co-ops. And for instance, if you have kind of a circular economy within your co-op, so you have freelancers that are working with each other or whatnot, and they can pay themselves in Circles, then you have basically a group of many people using Circles. But if they want to transact with people outside that group, you will most likely want to do that via fiat money. So the idea would be that the group lists their group tokens on a DEX, and people would buy the group tokens with euros and use these group tokens to pay people in the collective. So this way you get a backing for the group tokens, and if the group accepts the group tokens as internal currency, then you can have really nice economic activity around that.
Okay, that sounds like bootstrapping the thing, but could it not be another way where the Circle, like you guys, make it so that, I don't know how, by incentivizing so the spreading of the token so that it becomes of... Because when I look now at CoinMarketCap and I don't see CRC, I wonder, I have many questions, and I say, is this legit or no? So I understand that this is really coming bottom up. But I wonder.
Yeah. So it's really bottom up, and since everybody can create their own tokens and mint basically as many as they want. So if they have a botnet, the only thing that protects you against that is the web of trust. Yeah, it's not practical to use the individual tokens in DEX scenarios. But for groups, that's very well possible. And I think we will create some circles groups as well. But it's really meant as a feature for the people out there to create their own groups. So I think we will have a group for our wallet development, for instance, and maybe for other associated parts.
Last input. There's another token that has to, what's it called, like proof? It's something human of gnosis, or?
Humans of Gnosis,
What's
yes.
the relation with, is that the right name, and what's the relation?
That's actually a group currency. So version 1 of Circles, which is the version I showed today, also has a group feature already, but it's an additional contract that registers as an organization in the trust graph. So it's not very well integrated into Circles, but it was a first test group that was created and was actually backed with GNO tokens, or is still. And yeah, that's the very first asset-backed
So
Circles
CRC,
group.
human of gnosis, and GNO token. It's not easy to wrap your head around it, but yeah, I understand that we are building it, so thank you.
I just wanted to add to your question, but you already brought up the Humans of Gnosis, and I think that's definitely a group we want to continue. I don't, and it might have a valuation on DEXs, but I don't think it will feature soon in CoinMarketCap because it's not going to have a market capitalization of hundreds of billions of dollars. So. I mean, I don't know how many Humans of Gnosis are going to, yeah. I would just not, I don't think that's the expectation we're trying to build for, is to reach the top 10 of CoinMarketCap with any particular group. Like, I mean, yeah. Even if all groups together are significant, maybe then, but they wouldn't add up necessarily together. So I think you will see circles in DEXs, but not listed in CoinMarketCap. So that's inevitably, I think, an expectation that we should try to work with. Yeah.
Never say never.
But just to finish, can it not be a world where one angel investor of some sort say, okay, this is actually really cool, I want to bring visibility from Berlin to the world, let's put some angel, or?
I was part of the previous team, and I think the circles was not meant to be like that. I think it was really more thought from the community side of it. Like, instead of a speculating coin, it was more to be a tool to use for communities to do transactions rather than just being in a market and create a market of speculation. But it's very difficult to get to the global part because you will have to have a lot of communities first. Like, ideally, Circle will get popular in the communities, and eventually the communities will decide where will Circles go rather than the other way around. At least that's how Circles has been thought from the beginning, really community driven.
I think also for the group part of Circles, Martin will give a talk tomorrow where he will bring up some more ideas what can be done with the groups. I don't know the contents of the talk yet, but I'm pretty sure it will have groups in it. Any more questions? Did everybody manage to finish the code quest, or should I come around and do some debugging session? So I think we have plenty of time left. So if oh, okay. Do you have an error message from MetaMask? Sometimes, eventually it should, maybe to repeat the question for the stream, she had an issue where the button was just spinning at the sign-up stage. And I think eventually it should settle. So sometimes it's like the fees are not enough when the chain might be congested. But I'm sure you have tried it again and the same happened. Oh, interesting. Let's check which step that was.
Check out the last range calculate maximum transfer.
Can you check out the register at Circles?
Maybe after.
Oh yeah. True. Okay, so if there are no more questions, then I would stop the workshop here and see you outside and talk in person.
Hey everyone, this is Guru. I'm one of the co-contributors of the Waku project, and I do developer relations for Waku. So, starting with the problem statement, Web2 communications do not preserve your privacy out of the box. So, this is something that exists in all forms of Web2 communication, whether you use sockets or anything that involves HTTP endpoints. So, your interactions online can be eavesdropped by multiple centralized applications. And your social graph and your private metadata can be exploited by these centralized gatekeepers. So your messages that you send on Web2 are mostly linked with your IP addresses, and your IP addresses can reveal a lot more information than you actually think. So basically, it can reveal the sender and the receiver, and also information like location of the sender and receiver. And along with this, a lot of private metadata, which can be for application-specific processing. And this information can facilitate large-scale censorship or surveillance attacks around the world. It can also hinder freedom of speech. And this is not a problem that exists just with chat, but pretty much with all the Web2 applications that can be in gaming, marketplaces, location sharing apps, or anything that involves machine-to-machine or machine-to-human communication. So to solve this, we've been building Waku. Waku is a family of robust censorship-resistant communication protocols designed to enable privacy-focused messaging for your Web3 apps. So we've stick on to 6 main ethos, the first one being censorship resistance and privacy. And we also have modularity by design, which means that you can use Waku with any blockchain of your choice, or it's not even a blockchain. Waku is something that can complement a blockchain. Waku is also adaptive. We have different implementations for different resource-restricted environments. And it's securely scalable, meaning that we don't compromise on the level of decentralization for scaling. And most importantly, I think personally my favorite of all these ethos is DOS protection. A lot of Web3 networks that exist right now are not DOS protected. And even if they are DOS protected or rate limited, they use centralized methods to do it. But at Waku, we've integrated RLN, rate limiting nullifiers, which make sure that we have a privacy-first approach for rate limiting. We'll be talking about it in detail in the upcoming slides. But moving ahead, these are some of the misconceptions that we usually have. Waku is not a blockchain. Waku is not just a chat messaging protocol, but Waku is a generalized communication protocol that you can use for sending any kind of data between nodes. It's more on the network level, built on top of UDP and TCP. So you can pretty much send any kind of data less than 1 MB. And you can use Waku in multiple use cases, revolving around gaming, marketplaces, state channels, and again, anything revolving around communications, which can be machine-to-machine, machine-to-human, or human-to-machine. So talking about the history of Waku, it all started in 2013 when the Ethereum white paper was released. We had the holy trinity of decentralized web, which was Ethereum for consensus, Swarm for storage, and Whisper for communications. But over the years, as a developer community, we've forgot to focus more on other things like Swarm and Whisper. And there's this misconception that blockchains are Web3 and there's peer-to-peer technologies and a lot of other technologies which also contribute to the Web3 vision or the Ethereum vision. Until 2020, there was not much of teams working on Whisper as a protocol for R&D. But in 2020, Waku V1 replaced Whisper in the status app. Waku is an iteration of Whisper. We had a lot of architectural changes happen in the course of time. And in 2020, Status is a messaging app which migrated from Whisper to Waku. Today, we are trying to evolve as the standard for Web3 communications. We are trying to be as unopinionated as possible, and we are trying to build for the open source communities around in Web3. So we also had a mention in Vitalik's blog in December last year. Vitalik mentioned that Waku Whisper still exists as Waku, and it contributes to the deeper vision of peer-to-peer communication, which can complement something like Ethereum. So this was one of the diagrams framed by Gavin Woods, where Ethereum smart contracts are for consensus, Swarm for content address storage, and Whisper for dynamic communications. So dynamic communications should be gas-free, and that's the same ethos that we are trying to stick at Waku as well. Waku does not have any consensus as a network, so it's open for anyone to push and subscribe to messages from a particular namespace. So going ahead, Waku in a nutshell has two main components. The first one is the Waku protocols, which are a family of protocols, and the Waku network, which is an opinionated network that we've built at Waku. So talking about the distinction of nodes at Waku, we have two types of nodes: light nodes for resource-restricted environments like your mobile phones, mobile apps, or browser apps. And we also have relay nodes, which usually run in resource-rich environments like clusters or VPS servers. So based on the category of the node, we have different protocols to cater each of these categories. The first one being light protocols, which can work in resource-restricted environments, and relay protocols for the resource-rich environments, respectively. So this is a diagram which can visualize the adaptability. Waku can work in something as resource-rich like a cluster, VPS, or home server with relay protocols, and with lighter protocols, you can use it on phones and browsers in less bandwidth environments. So today I'll be covering mostly the light protocols. We have detailed documentation about relay protocols in our developer documentation. And we also have RFCs and research articles for each of these protocols. But light protocols are the ones that are mostly used in consumer apps or in hackathons. So talking about light protocols, we have light push, filter, and store. And each of these protocols have a different purpose. But if you want to send a message data into a content topic, you'll be using light push for this. Light push basically pushes a blob of data into a content topic. And we use filter for retrieving or subscribing messages from a content topic. And content topics are nothing but namespaces that exist within the Waku network. And store is a complementary protocol that we have for providing temporary storage for your messages that you send on the network. And also, to talk a bit more on store, we don't have any guarantees or assurance with store protocol as of now, because Waku focuses more on the transport side of things. But for long-term storage, we definitely recommend you to use something like IPFS, Filecoin, or Codex for long-term storage. And it's important to have perpetual storage, because at Waku store protocol, the content of the store protocol usually gets cleared out every 30 days. So it's more for temporary storage. And going ahead, looking at the content topic architecture, the whole Waku network is divided into content topics. We have different namespaces, like over here we have topic A, topic B, and topic C, which are 3 different content topics. And there can be multiple nodes listening to different content topics and sending messages to different content topics. And all these content topics are public by nature, just like Ethereum. So anyone can send a message into any content topic and subscribe messages from any content topic. So for any kind of access control, it should be cryptographic. You can use something like LID protocol or something like threshold for doing this before you send data into the content topic. So it's important to set up encoders and decoders to make sure that no one else uses the same content topic as you do. We also have, for simple use cases, we have encoders and decoders within our SDK, but for more deeper and wider use cases, we definitely recommend you to check out other access controls. But the way in which we declare a content topic is based on this particular template. It starts with the application name followed by the version of the application, followed by the content topic name or the category, finally ending with the encoding type. An example for this would be supercrypto, which could be a name for your application. Version could be 1, and notification can be the category of messages that you communicate with this content topic. And you can also have proto as the encoding. So we use protobuf for encoding and decoding in our documentation. So based on the encoding standard that you use, you can change it accordingly. We also have a structure for each and every data packet that is getting sent into the Waku network. So we have different terminologies right now. Some people call these data packets as messages. Mostly developers refer this to be messages, but semi-technical people misunderstand messages to be just chat messages. So messages here means that anything that gets sent from one node to the other is, that's what we call messages over here. And the maximum limit, as I mentioned before, is like 1000 KB. So we have the content topic as the first attribute that goes in. The content topic is used for content-based filtering, and you should be filling the content topic into which you want to push the message, followed by payload, which basically contains the message data. And we also have a meta attribute for application-specific processing, followed by timestamp, which has the time of the message when it was sent. And finally, we have an ephemeral property, which can be a Boolean property. Here, Waku is not ephemeral by default, which means that the messages that you send into the network are evaporatable. So it's not getting stored in the network. So if you want to use store protocol, you should be setting ephemeral to true so that the message stays on the network for 30 days. Anyone can contribute to the Waku network by running your own node. And we have a Docker compose command if you're interested to try running a Waku node. There's no incentivization for running a Waku node yet. Incentivization is currently work in progress. So yeah, this is the simplest way to run a Waku node. And we also have technical research specifications in this RFC. It's available on rfc.wac.dev, which is our request for comments in a collection of all the RFCs that we've had for the protocol. So another important thing that we consider at Waku is vendor lock-in. So there are a lot of Web3 protocols or products which still have vendor lock-in, which means that once you start using the protocol, you cannot migrate it to a different one, or you cannot self-host it in a later stage. So making sure that Waku doesn't have a vendor lock-in was very important in a lot of decision making. So Waku is privacy first by design. And we have two ways of using Waku. The first one is running your own fleet of Waku nodes or running your own network. Or the second way is using the Waku network, which is a network that we've federated for developers or for projects to readily use Waku without having to do much of federation things. So when you run your own custom network, it's still privacy by design. And even in the Waku network, it's privacy by design. We don't have any architectural changes. And all of the code for running a node is available on GitHub. It's open source. And both running a custom network and the Waku network can provide you modularity and adaptiveness. The only differences or the only advantages that you have with the Waku network is it's batteries ready, which means you don't have to federate. You can just use the Waku network along with the SDK to send and receive messages without much setup. And it's also rate limited by default. Not by default, but you can choose to opt out of it, I believe. But then rate limiting is a very novel feature that we've introduced with the Waku network. So no one can send like 1,000 messages in a minute to put Waku network down. So rate limiting exists in Waku. And we also have node operator incentivization work in progress with the Waku network. With the custom network, you don't have to have a incentivization for your node operators. A lot of partners that are using Waku right now have an in-house fleet of Waku nodes running, and they don't have any kind of incentivization for it, obviously. But if you use the Waku network, you can expect incentivization to be there for node operators down the road. But we are actively researching on it. It's work in progress. Also, the only closest technology that can be compared with Waku in the Web3 space is libp2p, at least for me personally, because we have communication protocols like XMTP and a lot of other protocols which are actually built on top of Waku. So XMTP uses Waku nodes behind the hood. So I think the only low-level protocol that exists in the Web3 space is going to be libp2p. And the relationship between Waku and libp2p is both of them use gossip sub, and Waku is built on top of libp2p. It's a service network built on top of libp2p. And gossip sub is the mechanism in which Ethereum nodes talk to each other. So Waku enables discovery in a decentralized and privacy-preserving manner. And by default, libp2p does not preserve your privacy. Your IP addresses are getting exposed when you use libp2p. So these are some of the modifications that we've architecturally implemented in Waku. And with light clients, libp2p has JS Waku, which is the TypeScript implementation of libp2p. And in Waku, we have JS Waku, which is pretty much solving the same problems. And we also have protocol muxing, working, a compatibility to work offline, and native roaming, and all of these features in both libp2p and Waku. But apart from these features, Waku also provides you some upper hands, like Waku is a service network. It's also a turnkey solution. And we implement economic spam protection or DOS protection, like I mentioned before. So these are the advantages of using Waku directly rather than using something like libp2p, which complicates a lot of your development process. Talking about RLN, RLN stands for rate limiting nullifiers. It's a technology that was collaboratively built with privacy scaling explorations in the Ethereum Foundation. So we had a lot of researchers from VAC, which is our research unit, work with PSC team for shipping out this. And Waku is one of the first few projects who is trying to implement RLN on a production level. So we have two segments in decentralized rate limiting process. The first one is a membership contract, which has a membership set deployed on the smart contracts. You can deploy this membership contract on any blockchain of your choice, but right now it's available on testnets. And yeah, this membership contract interacts with the zero knowledge proof that is attached with every message that you send into Waku. So this is how we implement RLN. So every time you try to spam the network, or every time you cross your rate limiting, the network basically doxes you. So you get punished if you cross your rate limits. That's how the whole concept of RLN is implemented in Waku. I also have a quick simulation of how fast a Waku message can be sent. It starts from Singapore, goes to India, now to San Francisco, and to New York, and finally back to Frankfurt. All this happens in like 20 milliseconds, and it's simulated with a real-time size of 2 KB data with real-time machines. So this is how performant and competitive we are trying to be when compared to Web 2 communication protocols. And we also have a couple of resources. The first one that I want to highlight is the developer documentation. It's available at docs.waku.org. And we also have a list of ideas that can be built on top of Waku. They are community curated ideas, and you can find them out at ideas.waku.org. And finally, you can find all the presentations, videos from all the presentations that we've done in the last couple of months. And we had like around 90 projects submitted at different hackathons for our bounties. So all these projects are visible at Awesome Waku repository in our GitHub. So these are the three main resources that can be useful in exploring more about Waku. I also want to highlight a few of the projects that use Waku, some of the projects from hackathons that were around the world. So the first one is Block IoT. The project implements an IoT system that can communicate using Waku protocols. So if you want to make a home automation system, but you don't want a centralized entity to know about your electricity usage or any kind of metric, you can use Waku for this. And you can also connect different IoT devices for this. So this was one of the most exciting projects we've had. And we also had Becamos, which was one of my personal favorites. It was from ETH Rome last year, and it basically implements a privacy-preserving wallet-to-wallet location sharing. So right now with the location sharing options available in iOS or Android, the location is obviously shared with decentralized entities like Apple location services or Google location services. So this particular application enables you to share the locations peer-to-peer with the wallet of your choice. So it was really sleek, and the application was pretty much production ready. So this was one of my favorites. And we also had a couple of games built on top of Waku. We had a multiplayer, a trump card game built with Waku where you can collect cards and also battle with other people. So you can also build fun things with Waku. And one of the recent buzz around the AI, a convergence of AI and blockchain is data privacy. Right now, when you use centralized LLM platforms, all the LLM platforms collect your data, and they need to do it because they use it for recursive training in a later point of time. But it makes no sense for them to collect your identity coupled with the data. So that's where Waku can be a middleware, making sure that the prompts that you send to any LLM platform get decoupled from the identity. So right now, the platforms can find out what you're searching for on these platforms, and they can advertise you based on what you're searching for. And we also had a recent buzz that most of the data from ChatGPT was traded with another centralized entity for just in the name of machine learning, which doesn't make sense because people obviously search a lot of critical things in these LLM platforms without understanding this big risk. So this is where Waku can come as a middleware, and you send your prompt to Waku, and there's a filter node running on the other side, which basically takes in the prompt and processes the prompt. So Waku can be a good fit in compute marketplaces, in LLM platforms, and in the whole sector of machine learning. Yep, so if you want to learn more about Waku, if you want to see some code snippets, you can find them at docs.waku.org. We also have some example apps set up for you to try out. It's available at examples.waku.org. And please feel free to join our Discord where we post our announcements every week. We also make sure to be as open as possible. We have around 17 co-contributors working for the Waku team, and we post out our weekly updates over here and also on our Twitter, so make sure to follow us over there. And we also have a Next.js boilerplate for anyone who's trying to build on top of Waku. I know there's a lot of pro-privacy hackathons coming up in the next couple of weeks. There's ETH Berlin followed by ETH Prague. So all of these hackathons have privacy as the core angle. So if you want to experiment with Waku, make sure to check out the Next.js boilerplate, which has less than 100 lines of code, but has a complete implementation of Waku. I can also run through the code real quick and show you how the code should actually look like. So we are also actively working on refactoring our SDK. So we'll be having a new SDK in a couple of months or a couple of weeks, depending on the development that we're having. But yeah, right now we have an SDK available for JavaScript, and it's very simple. You'll just have to install Waku directly from our documentation. And then once you do that, you can import the dependencies, which are listed here. Create light node for creating a light node instance, and wait for remote peers is for peer discovery. And we also have encoders and decoders within our SDK, where we have create encoder for the encoder and create decoder for creating a decoder. And as I mentioned before, we use protobuf as the encryption and decryption standard for most of our documentation at least. So we also installed the particular package, protobuf.js for JavaScript. And after that, it's pretty much simple. You just declare a content topic. The content topic should follow the naming convention that we discussed before. And after that, you create a message object. Over here, I have a chat message object, which has a timestamp and a data. So this is how you template a data object that gets sent into Waku. And once that is done, you can have a function for sending data, which will be coming back again after we set up the node. But before that, we have a use effect hook, which sets up a node by using the create light node command. And in the create light node command, you can pass this specific thing called default bootstrap. You can set it to true if you want to use our default bootstrap nodes. We set up a bootstrap nodes to make it easier for developers to build at hackathons or just to experiment with Waku. So you can set it to true if you're trying to experiment, or you can also set a particular set of fleets as the bootstrap nodes, alternatively. But going ahead, you just start the node by node.start, and that should get your node started. And after the node is created, that's when you have peer discovery. So for this, we have a function called wait for remote peer. This function basically waits for other peers to connect to your Waku node. So the way it works is light nodes get connected to another relay node, and these relay node carry out most of the resource consumption or resource operations that require a lot of resources. So once the remote peers are connected, you can go ahead and create your encoders and decoders. For this, you can just define an encoder using the create encoder function. Inside the create encoder function, you can have the content topic into which the message should be pushed. And you can also set the ephemeral to be true or false over here. So if you need to store the message, just set it to true. And after that, you can set encoders. And then similarly for decoders, you just use the create decoder function to pass in the content topic. And then your decoder should be set up successfully. And you also need a callback for retrieving all the messages from your filter nodes. So it's pretty much simple. You have all the code snippets available on our documentation. You can get the payloads in different formats, and you can find more in-depth explanation about this in the docs. And the way in which the filter nodes work is based on subscription. Waku follows a pub-sub architecture, which means that you subscribe to a particular content topic and you keep receiving messages from the content topic. So that's pretty much it. I think the only part that we missed is sending the data. So for sending data, you just have to create the message object just like we mentioned before, and then serialize the message using the encoder that we just created. And finally, you can use lightpush.send function for pushing the message into the content topic. You'll just have to pass in the encoder and the payload into this function, and it gets your message into the content topic. So if the ephemeral is false, the messages getting transmitted are real time, which means that you cannot expect the message to be saved in the network for a particular amount of time. So yeah, that's all about sending, receiving, and storing messages with Waku. And this boilerplate is available on GitHub in the link that I shared before. And it also has a very simple UI that explains you step by step about the processes that are happening behind sending and receiving a message. And this can be the most minimal example that you can try. And we also have other applications like Waku, which was developed by one of our core contributors in our Waku team. This is basically an application where you can host question and answers. So you can just share the link with other people, and they'll be able to ask questions through this link, and it'll pop up for me over here. And I also believe polling is available, or it's going to be available really soon with Waku. So we are trying to build all these experimental stuff. We have a couple of open bounties for developers to earn a couple of maybe $1,000 or $2,000 for doing all these examples. So you can find more about Waku bounties at bounties.waku.org. We are just trying to implement Waku in more of non-chat use cases, because there are quite a lot of chat applications that use Waku. So we are trying to explore non-chat use cases. But when we talk about the enterprise integrations with Waku, Waku is being used by projects like XMTP, also the Graph. The Graph uses Waku in a very novel way in which they try to decentralize the indexers by a pub-sub communication. So Graph, and we also have Railgun, which is a privacy-focused layer 2 on top of Ethereum. So Railgun also got a mention from Vitalik in the last couple of weeks. So they've been buzzing in the Web3 space for quite a while, and they are using Waku as well. So there are a couple of projects that use Waku in the production, but we also acknowledge that there are a lot of issues with the SDK because of the rapid changes that we are doing and a lot of features getting delivered. So feel free to join the Waku Discord, and if you have any questions or if you need any support, the co-contributors are always available to help. So that's all from me for today. But if there are any more questions, I'll be happy to take a few questions.
Hi, thank you very much for the talk. Could you elaborate on the censorship resistance? For example, I saw that you had to connect to Bootstrap nodes at the beginning, and the network packets could still be monitored and blocked by an ISP. Is there some workarounds around it?
Yeah, so censorship resistance over here is in a way that we don't need the identity for a message to be published or subscribed. So let's say there are two actors in the node, Bob and Alice. So if Bob sends a message into a namespace or a content topic, Bob will be sending it inside the namespace, and he doesn't necessarily have to, provide any wallet address or any kind of identity to support this message. So the IP address is also not included as a part of the message. And the other end, where Alice or other subscribers are subscribing to the particular namespace, will not know the message is from Alice, is from Bob. So that's how we decouple the identity of the sender and receiver by using namespaces. And with libp2p, it's you can definitely find out the IP address of the peer who you are connected to. But with Waku, that's where we are having a novelty where you can't find the IP address of the connected peer.
You talked about chat applications, but for example, let's say you wanted to build something like Farcaster, decentralized Twitter. Could you describe how that would work? Like, I understand there's a storage solution for it, or? Yeah.
So for Farcaster, I assume there is a need for storage, definitely, because once it's something like Snapchat. Once you send a message and once it's delivered to the other peer, the message is not stored on any specific database or any specific storage. That's how Waku naturally is. For proof of concept, for something like Farcaster, you can definitely use Store protocol, but we also want to be transparent that Store is currently centralized. But we also have other solutions like Codex, which is a content address storage like IPFS or even IPFS. They can be the right fits for these use cases. So you store these messages on IPFS, or if a user wants to send an image over Waku which exceeds 1 MB, they can store it on IPFS, and the CID gets transmitted on Waku. It's not the whole file getting transmitted on Waku. So this is how we are trying to solve messaging use cases, and Status has been already doing it for the last couple of years. But for Farcaster, definitely, they can readily implement Waku, and it can solve a lot of privacy issues that exist in social media applications in Web 2.
Thanks for the talk. With respect to RLN, is the rate limit configurable? And if it is, how is it configured? Who gets to set the rate limit?
Right. So right now, RLN is still experimental in our stack, but we've been getting a lot of good feedback from different teams who are trying to dogfood it. But for the network, we have a rate limit. For at least the Waku network, we have a rate limit of 1 message per second, which is just for the current timing. But then RLN depends on the reputation a system that you create for a particular identity or a particular peer. That way, you don't essentially get to spam the network with like 1,000 messages a second, and you get blacklisted and your IP or your identity gets doxed once you cross the limit. So RLN, there's a smart contract deployed on the blockchain, which basically has the membership set of all the peers or all the memberships generated from the contract. So this is the only segment where Waku has a blockchain part of it. Apart from this, Waku is more of a privacy tech protocol than a Web3 protocol. But yeah, right now for the Waku network, we have 1 message per second as the limit, which is totally customizable depending on the shared resource that you have in your set of Bootstrap fleets. Yeah, so feel free to reach out to me if you have, I can take a few more questions.
Thank you so much for the presentation. First, I have a question around, you mentioned that the graph is using Waku. Is it using it like a Kafka cluster, like following like a PubSub architecture? If it's using it like that, those are many, many calls and you will definitely hit the rate limit. How are they handling that?
Yeah, so right now, all the integrations that we have currently don't implement RLN. RLN is something that we've implemented only in the Waku network. But the way Graph uses this, Graph has a separate team called Graph Ops within their organization, I believe. And Graph Ops has GraphCast, which is one of their, exactly where Waku is being used. And also, I believe, Subgraph Radio. So that's where Waku is being implemented. So right now, they have they've just statically declared the rate limits for the time being. They don't implement RLN or any of the decentralized rate limiting as of now. So they have like a static number defined to the number of messages per second, which is not the right way to do it. But the Graph team is also helping out with us in dogfooding RLN. But it'll be in production only after it's battle tested for quite some time. But yeah, that's how Graph is using it.
And I have one follow-up question. And in such enterprise scenarios, there's a lot of data privacy issues and regulation that companies has to follow. When using Waku, the data is just decentralized. The data is anonymized, and there are no regulations there. How does it work?
Yeah, it's very tricky to be solving this particular problem in this space because there are a lot of bad actors as well. Like Waku can also be used for a lot of dark fi use cases or a lot of use cases that cannot stick to the ethical values, I would say. But in terms of privacy, it solves a lot of bigger issues like people who try to use Messenger on a Web2 platform. They are more vulnerable to be every time you send a message on a Web2 platform, the general Web3 public who is not much technical would not know that their message is passing through a lot of servers, a lot of HTTP gateways, and it can be intercepted anywhere at any point of time, even if they are encrypted. So that is the biggest problem that Waku is trying to solve. I'm trying to be more permissionless and more trustless. So there are a lot of bad actors, definitely, but we are trying to address all these problems on a long run. Yeah.
Thank you.
Thank you.
Thanks for the talk. One question. As I understand, the relay nodes are acting as a storage for the messages itself. So the main namespaces, storing the namespaces with a payload. So how do you guys, or how it's in a scenario when a certain set of nodes keep these, or this node namespace, they are detached from the network in a case of a censorship, for example. What does it mean to the network in a whole? I mean, is this namespace completely lost? Is the data completely lost? Or is it somehow replicated between the nodes?
Yeah, so namespaces are primarily used for content routing. So they are like an address through which the messages go through. And like on a storage perspective, right now the store nodes, the content topics only store the messages if the ephemeral is set to true. But on a long run, if Waku is used with something like, let's say IPFS, that's where you can make it completely ephemeral, where you don't lose the messages. And there's also another problem that we are trying to solve at Waku, that the message delivery is also not guaranteed right now. Like you don't know if a message reached to a particular node if you send it with Waku. But there are many projects that implement novel mechanisms like pinging or sharing a secret to make sure that a message was delivered. So these are all in proof of concept stage. Different enterprises are using different ways to solve this problem. But when we talk about namespaces and the evaporability of evaporatability of storage. I think it's mostly like namespaces are just for content routing rather than content storage. But for solving this issue, I think something like IPFS or Codex is going to be the answer. So we are actively working with these storage protocols to understand the requirements. We've been doing a bunch of things with IPFS, but it's pretty hard to implement storage with IPFS without having to depend on a HTTPS gateway. So if you want to run an IPFS node locally and if you want to pin the file, it's pretty hard. But if you want to do it with a gateway service which depends on HTTPS endpoints, it's possible, but we don't want to depend on a HTTP endpoint for that. So that's the only blocker that we have right now with storage. Yeah. Cool, then I think I'll wrap up the workshop with this. But if you have any more questions, feel free to reach out to me. I'll be happy to take it one-on-one. Yeah. Thank you.
Welcome everyone. Thanks for the participation in this panel. My name is Arman. May firstly introduce yourself. My name is Arman. I do a validator communication at the Gnosis chain.
My name is Chuy. I am community manager for DappNode.
Hi, and I'm Sebastian, founder of Hopper, working on privacy.
Yeah, today I'm going to talk about exploring the validator universe for Gnosis chain. And end after this discussion, we will announce a raffle result for the winner of the DappNode. Okay. Let's start. I have 4 topics. Firstly, we will try to understand our Gnosis chain fundamentals, and then what you can do as a node operator, and our current developments and ongoing works, and we will talk about some challenges. So who I am, I do a validator comms at the Gnosis chain. My main goals is onboarding more solo stakers on Gnosis chain, and also try to bridge between core devs and infra team and also community, the whole intersection. I also try to improve the tools we have for increasing more accessibility to onboarding more solo stakers, and also continue to support validator community for network health with my Chewy also helped me for this purpose. So our fundamentals on Gnosis chain, we have a beacon chain. We have a dual token model, XDAI for the gas, GNO for the staking and the governance. We have 5 seconds block speed. We have same hard fork timeline with the Ethereum because we have a beacon chain, and we did a Chapella, we passed the DappCon, and the next hard fork is a Pectra. It's planning at the end of the year. Also, we work with the same clients with Ethereum on execution layer side. We have Nethermind, Ergon, and Get. Get is still on the onboarding process. We have some housekeeping works. Probably you can use a Get as an execution layer client at the end of the summer. And also on the consensus layer side, we have Teku, Lodestar, Lighthouse, and Nimbus. So it's really important to have a client diversity on the Gnosis chain. We try to onboard more and more clients for the improving the diversity. So another fundamentals things is you can run a node with just a 1 GNO. It is super important to have low requirements for the onboarding more solo stakers. And also you can run a node on small ARM-based mini computers, DappNode, or own device. I would recommend DappNode, or if you want to collect on the market some the devices, of course you can run a node. And the bandwidth side, you need more than 30 megabits for the running effective node. And also you need around 2 or 2 terabytes of data per month for the healthy way to run a node. And efficiency, if you have around 96 or 97%, it's good, not too bad. But if you have a 92 or 93%, you need to improve your running operation, because it's not a good efficiency. On Ethereum side, mostly 97 or 98% is good. On Gnosis chain side, 97, 98 is a little bit same, but the effectiveness depends on a little bit around our block speed. So yeah, I would like to give some numbers about our chain. We have more than 216,000 active validators, and also we have 1,700 active nodes individually. We have more than 70 countries where we have active nodes. So we should improve these numbers, especially the number of individual nodes. We try to onboard more solo stakers. That's why. And yeah, we want to work with especially solo stakers, DAOs like Kleros running a node on Gnosis chain, Hotpot also running a node on Gnosis chain, which is nice. And also we want to work with collectives such as OneHive is one of the oldest collective on Gnosis chain. They are still continuing on the nodes, running nodes, and also we have Seed Latam, AC, Ethic Hub, and Ethereum Mexico. We try to onboard more solo stakers for the amplifying and the expressing our culture, and I think our cultural values is really fixed, really fit the whole collectives, individuals, and rather than the institutional perspective. So you can see that our current number of nodes all over the world, morely is the Western countries, but we try to onboard more solo stakers, especially in LATAM and Southeast Asia and the Middle East. Yeah, I will go into the fundamentals. We have a strong relationship with the Dapp node. When the Gnosis Beacon chain launched, we started the campaign with the Dapp node, and we onboarded more than 500 nodes on the Gnosis chain. And also we have a strong community collaboration in terms of supporting, helping the validators, those who want to join a node, running a node on Gnosis chain. So on the mainly working on Discord side, and also we have successful campaigns. We started a new campaign 10 days ago, and with the new campaign, we will give a free GNO an online purchase, or if you want to buy in here, we will give a 4 GNO. So it's a really nice opportunity to starting a node operation on Gnosis chain. Maybe in this slide we can talk about our home solo or remote stakers. Who are they and what is what they are representing? Mainly, we as I said before, we onboard lots of Dapp node users. Currently, more than 400 individuals running a node with a Dapp node, so which is representing around 23% individuals. So it's quite a nice number, but we should improve this number for onboarding more validators. When we investigating and researching these individuals, they have 1 or 10 validators on Gnosis chain, so it is quite small numbers, but they are still continue to validating on Gnosis chain, which is super nice. I think this is representing a horizontal diverse for all the node operation, which is super nice. Maybe you can say something about the.
Yeah, so we at DappNode have been supporters of Gnosis chain from an early stage. This partnership that we have going on at the moment is the second partnership that we have with Gnosis chain, and we are very proud to have these numbers, which are great for the decentralization of the network. And there is an estimate of self-reported Dapp nodes that represent 10% of all of the validators in Gnosis chain. So taking in account that if we take it at an individual level and we talk about 1.7K active nodes, this makes for 23% of the individuals that validate in Gnosis chain are running Dapp nodes. So we are very, very proud to be supportive, because the common profile of this user is non-technical. So yeah, as you may expect, we take a lot of pride when non-technical users find their way to support the network as they have been.
Yeah, representing our 23% of individuals in the whole network is quite a nice number, but yeah, we should definitely improve with this new campaign, this device. Okay, what you can do as a node operator on Gnosis chain? Let's talk about a little bit these topics. You can do, of course, you have some task. If you have a node operation, you can produce a block as a vanilla block producer. The basic task, I think, is the most important task for every node operator. You can build a block and earn a rewards. APR around 13% right now. We have dual token model, and on the consensus layer rewards, you get GNO for the reward, and which is attestation rewards, Cinch committee rewards, and block proposal rewards. On the execution layer side, you can get XDAI for the transaction fees. So it's the basic task: start a run a node and build a block as a vanilla block producer. And
maybe to add here from somebody who runs a validator, so it's a bit of lottery, and this is, I think, kind of fun. So producing a block, obviously your node does, you don't have to do it, right? But if you run one validator, that happens only every 1 to 2 months or so. Yeah. And you don't exactly know how much you get, right? So I've seen some blocks where people earned actually quite a lot in fees. Maybe somebody made some mistake or something. So it's pretty funny, like one morning you wake up and there's like, $50 you earned for overnight. And yeah, then a couple of weeks something doesn't happen. Yeah.
Yeah, exactly. I remember when the inscription attack on the Gnosis chain side, some of the validators got some really nice number of course, it's symbolic numbers, maybe 10 XDAI, but it's giving a nice insight for if Gnosis chain grows, the execution layer also grows, and also the fee market also grows. Yeah, the opportunities and more. In this slide, I tried to explain if you run a node on Gnosis chain after the block producer, the vanilla block producing, there are some opportunities to have. We introduced the Gnosis 3.0 vision, and this vision includes a lot of payment-focused consumer app development, Gnosis Pay, Metri, Circles. And the vision is focusing on the payment, so all the payment dApps working on the Gnosis chain. So which means we will expect more transaction. We also expect more blocks, which means also it's linked to the fee market. So the basic motivation is secure payment network as a node operator, and earn rewards is quite nice. We have working with the Shutter team, Nethermind team, and Gnosis chain team are building a Shutterized Gnosis chain. Shutter team also here. Maybe they can say something about the whole, and also Lorik is here, about what they are building on the Gnosis chain, what they are expecting, and what is the next step. Yeah, if you have any microphone.
Hey everyone, my name is Loring. I'm with Shutter Network. And Shutter Network is basically an encryption protocol which promotes base layer neutrality, information symmetry, and accessibility. And in this particular context, we're working with Gnosis Chain and Nethermind on Shutterized Chiato testnet, which is actually went live yesterday, and we'll have a workshop on it tomorrow. But then in about 4 weeks or 5 weeks, you'll actually have Shutterized Gnosis Chain mainnet. And what that will do is introduce encrypted mempools to Gnosis chain. And that will mean that end users are protected from malicious MEV, like front-running and sandwich attacks, while still allowing for benign MEV, like arbitrage. And it will also protect them against censorship. So this is done in a decentralized way, using a decentralized keeper set. And as I mentioned, my colleague Yannick will be doing a workshop here tomorrow. So if you'd like to test out encrypted transactions, or if you would like to register your validator, you can do that tomorrow. Thank you.
Thank you. Yeah, as Ulrich mentioned, if you're curious about more details, Yannick will give a presentation tomorrow. Yeah, another good option is liquid staking with the Stakewise version 3. We will expect to launch end of this month or early June. The whole contract is auditing right now. What you can do with the Stakewise version 3, you can start your own vault on the Stakewise. So with this way, starting your own vault, you can if you're a collective, if you're a small number of friends, if you have any really small community, you can start your own vault on the Stakewise, and both collecting some rewards from the Stakewise and also collecting from the Gnosis chain consensus. So it's a nice opportunity to, if you're curious about, if you want to onboard, if you want to earn more money from the protocols. Upcoming developments, of course, we have really nice developments. And Gnosis VIP, we discussed at the forum Gnosis VIP, and it's passed right now. We try to onboard around 500 Hopper node operators into the Gnosis chain. So maybe you can talk. You can say something.
So I have a talk where tomorrow at 11 where I go in depth, but the TLDR is we're building a VPN that works just like a normal VPN that you might be familiar with, in a much more private fashion and actually decentralized and running obviously on top of Gnosis chain. And part of the proposal was there's people who run Hopper nodes, and if you run a Hopper node that is powering this data relaying under the hood, then you also get to run a Gnosis validator. So you get one GNO free of charge, which I find very cool. So yeah, incentive to start a Hopper node to then get incentivized to also run a Gnosis validator. Yeah, so we currently have about 400 Hopper nodes operational, so there's still some time left to register and be part of that one. Yeah. Maybe to add there, so on the Hopper side, we're also focusing very much on decentralization, because if you think about it, why care about decentralization, right? So, well, because we don't want to be like all the banks here where 5 guys behind closed doors have the say. So we need to decentralize who has a say in what gets included in a block, ordered, and executed. That's why, right? And we basically have very similar issues on the privacy side. If you relay data, who do you trust? Well, you don't want to trust one individual or one corporation. And yeah, so that network is relatively decentralized, and that's why we thought this would be a pretty cool opportunity to onboard another network, which is already kind of decentralized, although much, much smaller than Gnosis chain, and bring those folks to also run Gnosis validators, most of which also on DappNode, of course. So I think this one here, I think you haven't shown it yet. It's a very nice one. There's also another one, a Hopper node, which is also you can get through DappNode. Ours is a blue lid. This one has a very cool white-green. Yeah.
Yeah, it's also quite a nice history. Firstly, we asked we prepare some example design for the boxes and the lids, And then we haven't decided which one is good. And then let's ask the community. We start the survey, design survey for this device, and then the community selects some nice design, and then we print out the whole things. So it's a really good representing like community-owned network, and they are select their own design, and we did the end of the story. So yeah, the another good upcoming developments is Spectra and max effective balance. It's planning end of the year. Yesterday, Philip mentioned about the whole details, and if you want to learn about how the effects on Petra in max effective balance on Gnosis Chain, please check out the yesterday discussions on the Gnosis Chain YouTube channel. Another update is OBOL DVT. As you know, OBOL doing a cluster on the Ethereum and Holoski side. We also want to onboard OBOL DVT cluster, distributed validator cluster on Gnosis Chain. We tried to, first the OBOL team want to test it on Gnosis Chain because it's different to Ethereum one. We have a 5-second look speed. So after the testing purpose, they will share some reports about the testing result, and then we decide, yes, it's good or bad. Firstly, we will test with the 8 different entities, 8 different professional node operators, which is include Kleros, Gateway, some other names. And then the second step is if we get some proper results after the testing, we want to onboard more permissionless node operators, especially in the Solana stakers, using a DVT cluster. Yeah, DVT cluster is giving two nice options to the Solana stakers. One is of course economically, and the second one is a security layer. If you haven't any confidence with running a node, you can participate in the DVT cluster and delegate your some energy and some DevOps time to the professional node operators. So which is nice.
Just to add something in this part of the DVT, this is especially important when we talk about efforts to expand the network to other geographic locations. However, some of these geographic locations, like for example in Latin America, we have some infrastructure challenges. It is really cool to be a solo staker, but what happens when the lights go out or you have like some kind of problem with your ISP? So this is very important for these geographic zones because with DVT clusters, these communities are able to compete with more high-end validators that are in more developed countries. And this way, not only the cluster itself is more resilient with the validators that it's operating, but also the network is much better, can rely in these underdeveloped geographic locations as well.
Yeah, absolutely agree. Another one is Aragon version 3 and Geth. As I mentioned, Geth is expecting to run at end of the summer. I think if you want to say something on the Geth side, feel free to.
Do we have a mic?
Yeah.
Thank you. Yeah, so Geth has finally managed to sync the network. It's been a long struggle, but it's finally more or less ready. It cannot produce blocks right now, so I have to investigate this. But I expect, it should be there. I said end of summer. Maybe it's next week. Maybe it's December. I don't know. You never know. But yeah, I expect end of summer.
Thank you. Another one is Aragon. Aragon shared a latest version 2 version latest version 2 Aragon last week, and this is the final one, the version 2. We are expecting to implement the Aragon version 3 on Gnosis chain. So yeah, challenge. Of course, everything is not good enough for our telling. It's not a. We have a really tough challenge. So one of the main challenges is, of course, the client diversity. Is the Nethermind is a super majority client right now on Gnosis chain. So we have a Aragon and we will have a gas, but right now the Nethermind issue is important. If you run a node on Gnosis chain, please change your execution layer client. Is important for us. Of course, we have also node diversity. We have lots of individuals and solo stakers on Gnosis chain, but also have some big entities such as Chorus One, such as Gateway, such as Stakewise also. It is creating the centralized effect on the whole chain. So we try to push more solo stakers, push more home stakers, or cooperative structures, which is our challenge because of the running a node you need the time to do some work, for example, DevOps work. Every client, every device is not work really smoothly. Sometimes you lost your internet, you lost your IPS, sometimes you lost your electricity. So you need to put some efforts to running a node. So more people don't want to do that. So they delegate your token or giving the entities to earning some rewards. But I encourage more people running a node at home, or you can run a node with your friends. It's a nice opportunity. I know some people running a node with friends home. So if you don't have any proper internet connection or electricity, you can use your friend's home. The friend's home is the best home. So yeah. Another challenge is like geolocation diversity. As I mentioned, as you showed the map, the most of the nodes running at the Western countries, especially in the Germany, France, Spain, and of course US. So we try to push on board more different countries, especially in LATAM is the great opportunity to onboard more node operators from the LATAM, because they are highly interested in the Gnosis chain, especially in the other projects such as STI people or the DeFi people really active on that side. So if we have people from the LATAM, let's onboard as a node operator. It's a nice opportunity. This is our challenge. The centralization in terms of the geographically is a huge issue for us. And another one is lower block times. We have 5-second speed, and it is amplifying some bottlenecks your setup. The whole devices configure especially for the Ethereum side. Ethereum is a different the Gnosis chain side, so it is creating some setup configuration. You need to do some configuration for your setup, and for example, some storage problems or some effectiveness problems. It's great. Another challenge is staking entity diversity, as I mentioned, in maybe on the node diversity side. We don't have lots of institutional staking pools or institutional staking operators on Gnosis chain side, but it is potential issue for us, because if the Gnosis version 3, if the Gnosis 3.0 vision gets some successful, get as successful and get some proper result, the more people want to integrate on Gnosis chain, starting to their token and get some rewards. So it is potential issue for us. We need to create a balance between all the opportunities. Of course, the main challenge, I think, is supporting education and tools part. It is most challengers part because of the onboarding and not just buying a device or using any solutions such as clouds. You can buy a node, but after that you will have some issues starting a node, like client sync or any kind of how to use your device effectively. Yeah, DappNode is giving a nice opportunity to like a plug and play solution, but buy a DappNode and use their interface. But some of the people want to buy own device or use the existing device. So we try to educate our node operators or potential node operators, and we want to solve their problem with easy way. We have a dedicated Discord channel, but right now we just only have 1,070 people. If we onboard, for example, 5,000, we need a more time to educate these people or providing tools, especially providing tools running locally. It is super important things because of the Bootnode guys did tools that running Telegram. You can easily check their validator performance on the Telegram channel. It's nice to have a community contribution on the freely way, because the Beacon chain also our major consensus layer, execution layer explorer. You can also check with the Beacon chain, but it is not enough for just one proper solution. We need more than one, maybe two, maybe four, maybe five. So if you have an idea to build some tools on Gnosis chain side, please let me know. And of course, another huge challenge is a high coordination for the hard forks. As I mentioned, we have same forks deadline with the Ethereum. If Ethereum go to any hard forks, we also following the steps. Sometimes timeline is not exact time. For example, the DappCon one we did that 2 days earlier than the Ethereum one, but it is not a meaningful. It doesn't mean that every time we push 2 days or 1 week before. Maybe after the next fork, for example, Osaka or any other ones, maybe we will have maybe 1 month. I don't know. So we need a coordination for the onboard. We need a coordination for the network health, and it is really tough work for the creating a coordination, especially the more solid stakers, many solid stakers or individuals. The reaching out to this really messy guys because of the lots of people on the Discord side is a little bit messy for the learning some things, getting some updates from the what's going on the chain. Many people just following the weekly newsletter or monthly our newsletter. I try to send what's going on the Gnosis chain site in monthly. We did a survey and asked where they can find updates from the Gnosis chain side. Many people, they don't follow the Telegram or Discord or any kind of social media channels. They just only following the maybe updating just the 1 month. So it's really hard to coordinate with these people. Yeah, it's easy one, easy to starting a node, but the tough one is the coordination between these people. Yeah, maybe you can say something about the...
Yeah, I mean, maybe to start with some stats. Who here is running a Gnosis validator right now in the room?
Oh, yeah.
Oh, wow. It's a pretty good room. Everyone who wasn't raising their hand. So I guess actual challenges are whatever reason you have to not raise your hand. And I would say it's broadly, I see 3 things. I see technical, economical, and kind of cultural. So my answers will be around these 3. So technical is kind of clear, right? What do I do? Like, where do I start? So I would say I'm running 3 of these boxes at home. And maybe something that isn't so clear is DappNode is not, you don't have to buy the device. Maybe you have some device at home. So I had some other device at home. And what you can do is you just basically prepare a USB stick and you plug it into some old computer that you have. You switch it off, you switch it on. You don't attach a keyboard. You don't attach a monitor, nothing. You wait 20 minutes and DappNode is running there. It's magic. Good job. I would say 1 round of applause for DappNode.
Yeah, so yeah, a lot of people kind of like hesitate when they see that, oh, I need to get, you know, like a mini PC or I need to get like a dedicated hardware. This might be true like in a more like optimized like setting, but you know, like if you have like an old laptop just laying around or something like that, you can definitely use that for trying out DappNode. If you manage to make it operational, you can either keep it or, you know, like it is your own experience as a user, the one that is going to dictate like where do you want to go next. So regarding this, I would encourage you to go to the DappNode side. We have 2 flavors of DappNode. We have hardware that you can buy, or you can just download the software and flash the ISO to a USB thumb drive. And yeah, that's it. Just like Sebastian.
Yeah. So I would say that's pretty easy. On the other hand, of course, you have to have that hardware available, and that's maybe the second point economically, right? So you have to, especially if you want to run an archive node, which can tell you how much money did you have at some point in the past. Some people say that's not so important. I'm a bit a maximalist. I would say, you know, archive node is the values that we have to uphold. Everyone has to be able at all times to be able to run an archive node at home. That's, you know, my stance on the spectrum. So when you do that, for mainnet Ethereum, you need to purchase an 8 terabyte drive, which is literally the biggest like NVMe you can buy right now on Amazon. They currently can get them for $900. That's not cheap, right? So there we come to this economic side. So yeah, you as a validator want to make money, right? And what we're battling as home validators is we're fighting against economies of scale, against corporations which can afford to run machines in the cheapest computing centers because they don't run 1 machine like you do, but 1,000. Surprisingly or not, they get a better price than we do for electricity, for internet connection, for hardware, for everything, right? And this is like kind of this constant struggle that we have here, and that's why I think it's really cool to see these incentives with Gnosis Chain, because believe it or not, these fuckers, they don't get 4 GNO for every single machine they spin up on AWS, so that's great. So, you know, competing with economies of scale here. Yeah, at the same time, so there's a bunch of contributions to that. For example, you might think, okay, what if I fuck up, right? So I know, for example, in Ethereum mainnet, it's really scary. 32 ETH, that's 100K. Most places on the planet, you can buy yourself a very, very, very nice house for that. So you put that on a box to run a validator to secure a blockchain, well, that's tough, right? So even if you do have 100K and you don't want to buy yourself a house and want a secure blockchain, I would recommend start on Gnosis chain and take it as a test drive. Currently costs like 350, 300, 400, I don't even know what GNO is, $1 to run the validator. It's a good way to get started. And then there's this concern that some people have, what if my cat just bites the cable and my node goes offline? Do I lose all my money, right? And the answer is, no, you don't. Actually, Ethereum is kind of cool there because Ethereum said, well, you lose money when your node is offline. But how bad is it? Well, in Ethereum, it's roughly, and in Gnosis kind of the same, you lose about as much as you would earn on a day where you were online in average. Now, what does that mean? Right? Worst case scenario, Germany, right? So German people have infinite holidays, right? You have 6 weeks of holidays or something. Worst case scenario, you take your 6 weeks summer vacation and your freaking Dapp node goes offline the day you leave. You're 6 weeks offline. So 6 weeks is roughly 10% of the year. So 10% of the year you lose some money. So there's this inactivity leaks. But actually, that is about the same what you would pay for some professional staking service provider. They typically charge you 20%, right? So twice the 10%. So even in the worst case scenario, you're offline for 10% of the year, you don't pay more than you pay to a professional staking service provider, which rips you off of 20% of the fees. And you have somebody else taking care of your node, right? So that's actually pretty cool, right? And that's something that, the whole Ethereum ecosystem and the people who research these incentives, I really value and appreciate to enable us plebs to do that and really, again, compete with economies of scale. There's somebody who knows much more about that than me.
Yeah, I'm just saying if you have a nice neighbor that would, go into your home and reboot your server for you. Yeah, just saying. If, it's even cheaper if you have a nice neighbor that will accept, not necessarily knowing what they're doing, to unplug your computer and plug it back in.
Yeah. We have another recommendation from the past or question or something.
So I don't live anywhere. I'm the homeless, aka digital nomad. So I stake from other people's homes, and I don't have them do anything. I just install Tailscale, and I have a smart plug, so I can do everything from home. I can reboot it from home. I can do a hard reboot. I can SSH into it, and Tailscale is a super, non-technical installation. It's pretty much a one-click installation.
That's it. We have another comment over here. So in the meantime, that's a very sophisticated opportunity. Okay, I'm using at home. I'm in a similar situation as you are. I'm using the cheapo version, so on Amazon or wherever you can buy yourself for basically €5 a thing, like a clock that runs for 7 days, and switches off your machine very briefly and then switches it on again. Because you can, set up your Dapp node that it auto boots when the power reconnects, which is very cool. So yeah, that's the ultimate low-tech version of exactly that. But your setup is certainly more fancy there.
Right. Yeah, just about Tailscale, because this is also what I use. I had the story last week, so I was in Kenya for some interrupt. And my cable, my Ethernet cable that connects my Dapp node to my router actually fell off, the clip-sync thing was broken. Fell off under the gravity, and I was trying to connect with Tailscale. No, nothing happened. I asked my neighbor to go and reboot the server. Nothing happened. So that was a fairly stressful moment, but just pro tip, get proper Ethernet cables.
Nice. So yeah, I would say there's a bunch of things that really are being taken care of to make it nice. And even again, in worst case, there's not too much. The one thing you really shouldn't fuck up is when setting it up. So when it's setting up your validator, there's a wizard to do that. You have a withdrawal address to which you can withdraw your funds. Please back that up. I think people focus too much in the space on wallets and hardware wallets and stuff. I think put much more attention on the backup of that, on the mnemonic of that. Because if your hardware wallet burns, it doesn't really matter if you have a secure mnemonic backed up somewhere in a secure place. So I would say focus on that to secure things. Yeah.
Also, as the ecosystem keeps expanding, you were just mentioning an example of like a staking service, but there are some pretty cool things like being developed right now, like Stakewise vaults, for example. So you can actually become like an operator, and what's really cool is like this separation of the idea of a 32 ETH holder or even like 1 GNO holder from an operator. So you can actually become a really cool operator just by practicing with monopoly money on the Holesky testnet. It's exactly the same process as spinning up a validator on Gnosis chain. And you can practice with that. And once you feel that you're doing a cool job, you can set up a trustless vault in Stakewise and reach out to your friends. And yeah, I mean, maybe they want to, like stake their GNO or their Ether in your vault. And this is a way in which you can, like become productive by operating a node without necessarily having the economic resources to do so. So I'm very bullish on this part of the permissionless tools because this is going to get just easier. So yeah, if you're still thinking about it, become a node operator, and things will still develop.
Yeah, maybe.
So I just wanted to add one last thing that's kind of cultural to me. Like, we talk about crypto economics a lot, but ultimately, securing a chain or securing crypto economic network is about attention, right? So DappNode is awesome. I use DappNode on the 3 machines I run at home right now. But ultimately, let's think about, I like to sometimes think about the end game and where would it take us. Let's say DappNode did a perfect job, and they're doing a pretty damn good job right now. So you take this thing, you do absolutely nothing, you plug it in at home, you never ever touch it again, it just does its job, it always automatically updates, it always manages your funds, you're just happy. This ultimately adds nothing to the network. Why? Because, well, the DappNode guys are nice, but if all the magic is being taken care of for you, then maybe the magic is used against you at some point. So basically, to me, DappNode is a fantastic thing to get started. I really hope that we get into more of a culture of, appreciating the node home noddler, as some people call it, like nerdism, and just like, build your own setups, compile your own, Geth to run your stuff, or Aragon, or whatever you choose, right? Like, don't all go for the same thing. This is the first step, and it's a great one, but keep going, right? Keep evolving, because ultimately it needs attention. And I hope, and I see this in Gnosis much more than other ecosystems that I don't find as sustainable, that Gnosis really fosters this. And I think this attention here shows it that we do have some attention. So keep growing that ecosystem, put attention on it. Don't let some operator turn evil. We're building this kind of for worst case consensus faults. That requires, worst case consensus faults requires your attention to say, hey, DappNode, that doesn't look legit. That's not actually the client version we want. You're trying to force us on a malicious chain or stuff like that. That all requires kind of some attention of yours. It's not a lot, but I think this cultural shift is what blockchains really are about. And I'm very proud to, see where Gnosis is going there.
Absolutely, I agree. I'm curious about how DappNode can support the education to node operators and providing some tools on their channels. Like, you are organizing a educational YouTube series, as far as I know. Can you mention?
Yes. We recently published videos that we call the DappNode Driving School. So you can find those in our YouTube channel. And we also have the DappNode Crash Courses, which are live workshops with audiences Q&A that we run in our Discord. And so those are really cool. Those get recorded and uploaded to our YouTube. So definitely check those out. I think you'll enjoy them. And we're in very close contact with the Gnosis chain community. We have a bridged channel in the DappNode Discord and the Gnosis chain Discord. So this way, we kind of like keep the same communication, and it's also a great way to just store like some of the like the frequent questions that we get around operating nodes. So yeah, tools like that are very like important for the education part of it, and also like events like this, events like DappCon, give us a chance to talk to you about it, to get closer to the users. It always really amazes me how many people still believe that like if your Dapp node goes down, if you have a power outage, like you'll get slashed. And this is a myth. An attestation leak is very different from a slashing, and it's caused by very different factors. So it's always a great opportunity to talk to the community, and you can definitely expect this same level of communication if you join our communities, and yeah, you start telling us about your own experience as node runners.
Arman, I have a question to you. Where do I go if I want to get these 4GNO Dapp node? Because that sounds very good.
You can just visit the DappNode booth, and right now I want to announce our raffle winners in here. So great. Okay, just a second. Hopefully not me.
He's running a random number generator now.
Yeah, right. Show it on the screen.
Okay, here we go. Yes. Okay. We don't know who is he. Who is he or she? I don't know. The raffle is ended, and if you have this address, please reach out to me. Reach out us. We will give this device with a 4GNO as a special one. Anyone in this room? No.
It's the last digits.
It's 0x9B2D.
And also this number of tickets, yeah.
Well, then it goes to Arman.
Mystery, yeah. Whoa, nice. Any questions? If you have any questions, feel free to ask. It's the right time to talk about.
We have one more comment here and one there.
Thank you for the great panel. I know there's plans to run Gnosis VPN on Hopper nodes, but are there plans to run Gnosis VPN on Dapp nodes?
Huh, that's a good question. Come to my talk at 11 tomorrow, I would say. Yeah, so basically, absolutely yes. So Gnosis VPN, the clients that you will use to actually run this, will run on Dapp nodes, like other Hopper nodes also. Absolutely, yeah.
Yeah, I have a couple questions. Don't worry, it's a nice question. Actually, it's kind of the same question, but for 3 flavors of each. I'm going to start with you, Sebastian. You say everybody should be an archive node runner. For Gnosis Chain, the problem is that you have a block time of 5 seconds, which means currently you have roughly twice as, maybe 50% more blocks in Gnosis. Have you tried that for Gnosis Chain?
Yes, I'm running an Aragon archive node right now.
Oh, wow.
Yeah.
And how much space does that take?
On Aragon right now, Gnosis Chain is 1.95 terabyte. So,
wow,
yeah.
Okay, it's not too bad.
It's not too bad, yeah, exactly. Okay. I actually run, so I bought myself this ridiculously overpriced NVMe. Right. And so I'm actually on the same device running an archive node on mainnet, which is currently around 5 terabyte plus Gnosis, which is almost 2, so it just fits.
Okay,
yeah.
Nice. Okay, thanks. The other question is, at the beginning of the presentation, you said you could also run something on an ARM machine.
Yeah.
So basically for the same reason, fast block time, fast I/O. I wanted to ask you if that had been tried, because I'm curious. What kind of machine?
our very valuable community member Haurok shared his experience with the ARM machine. Is a super mini device, just experimenting, running a node. I will share with you the whole story.
Right. And then my question, because I'm a big ARM fan, like what you described about plugging a stick and booting, does the DappNode software support ARM as a platform?
Yes, we have. If you go to our GitHub repository, you'll find under releases, basically like 3 different ISOs. You can find an attended installation if you have experience installing Linux. It's basically a Linux installation. You just get to customize some of its settings. If you don't know what I'm talking about, you can try the unattended installation and it'll just happen.
It's magic and it works great.
Yeah. and yeah, we also have a release for running on Raspberry Pis. We have like mixed reports on that, to be honest. But if you're interested in talking a little bit more about running tests or similar stuff, let's talk about that.
Yeah. One more question? Or
What's your question without RISC-V?
Just ARM. We recently have an amazing team that decided to use DappNode for their own purposes, and they're using mostly ARM. So we've been receiving a lot of pull requests, fixing all the stuff in ARM that didn't work. So I think it works now. At least they haven't submitted any more PRs, so either they give up on us or it's working great for them.
Any question? Or if you want to, feel free to share your experience. Okay. Thank you for the participation in this panel.
Thank you.
All right, welcome everybody. Many of you have already discovered one of the biggest truths that can happen is that by the end of day 2 of any crypto conference, the speakers don't smell good. That's why the first 2 rows are empty. Cool. We're going to do a bit of a workshop on how to run Dapp nodes on the cloud. How many of you know Dapp nodes? Okay, for those of you, that's pretty good, that's 50-50. For those of you who do not know Dapp nodes, Dapp node is a free open source software that you can install in your own machine. And you can turn this machine into what I would say it's a pretty good node manager for running validators, for running any sort of like crypto or Web3 infrastructure. Now I'm going to show you exactly what do I mean with that. And I'm going to show you Dapp nodes. So Dapp nodes, right here. Dapp node is as I said, free open source software. And you install it in your machine, and it allows you to run Web3 infrastructure. And you do that by providing us with this Dapp store, where you can just choose the type of nodes that you want to run and the type of infrastructure that you want to run. Now, most of us want to, when we think about running infrastructure, we also think about running validators, meaning to do something that provides us with some sort of reward to do some work for the network. Unfortunately, this is not super easy sometimes. It's not extremely complicated, but most of us, or if you're like me, you're kind of lazy and you prefer to have something nicer that does not make you fight against the terminal that you don't fully understand. So if there is an easy way of running a node, I'll take it. And this easy way is basically going here and clicking for an execution client, a consensus client, putting your remote signer, choosing your relayers for MEV Boost if you want to use MEV Boost, and clicking apply, and then you're going to be running a validator. And that happens for several chains. That happens for Ethereum, Gnosis Chain, Luxo, etc. Not only this, but it's also kind of like a neat way. It has like a few features that make it very accessible for everybody. Like it has a VPN, meaning that you're supposed to be installing this in a dedicated machine. You're supposed to be doing this in a dedicated machine, and I cannot see this because I've got the timer. So let me just do it like this, so it's below the timer, and now I can see the rest. Cool. So Dapp node, as I said, is free open source software, but you need a dedicated machine for running it. Anybody knows why you need a dedicated machine to run Dapp node or to run validators? Why cannot you run it on your laptop? Because it has to be online 100% of the time. Once you close your laptop, it goes offline, you stop validating, you're not earning rewards. You might even get penalized, right? So you need a machine that's connected all of the time. Where do I get this machine? Well, I mean, you can get it yourself. You can just get a small factor PC. You can install Dapp node on it, and you'll have this UI that we have seen to guide you through the steps that you need to do. Otherwise, you can buy a pre-installed machine from us. And we have these machines that you can buy, and they come pre-installed. They're plug-and-play machines. They come pre-installed with Dapp node, and you can just plug them to your router, plug them to the power, and they will emit a hotspot, meaning that there'll be a Wi-Fi network in your house called Dapp node Wi-Fi. You connect to this with your laptop, and you follow the instructions, and you configure the whole thing. So that's kind of neat. It also includes a VPN. Anybody knows what a VPN is? It's a virtual private network. You are absolutely correct. And basically what it does, it creates a tunnel between the traffic that you're doing through the internet, and it basically makes your computer think that you are in a local network, in this private network, and you can communicate with your dApp node. So see, I'm connected to a dApp node. I'm connected to a dApp node here, but it's not this dApp node. We said that it's in a dedicated machine. It's not on this laptop, right? And it is in a machine like the ones that I was showing you that's at my dad's house. And I'm connecting to this machine, and I can access and manage my node from no matter where in the world I am. No need for SSH, no need for strange protocols, no need for terminal again. That's the main goal, is to bring, sort of, make it technologically accessible for everybody to be able to run a node. More neat things that we have. We have this dApp store that you have seen. It's a completely decentralized. Oh, you are a legend. Thank you. The timer just moved a little bit so I can see the rest of the screen. So you can see this dApp store. And this dApp store is actually, as far as I know, maybe the first. It was 2018 when it came out. So probably the first completely decentralized dApp store that has ever existed. And it's basically a repository on the Ethereum blockchain that says the list of the packages that are available for you to download. And under that repository, there's an IPFS hash for the content of this package. So basically, you download a Docker image. When you click here, let's just see an example. Let's go for a Hopper package, for example. When you click here on install, it'll ask us for the parameters that we want for our nodes. OK. And we'll just basically fill this. Let's do this. Which one do I have? I don't have Nethermind. Which one do I have? Well, basically, you just configure this, follow the instructions, configure the Hopper nodes, and go on to submit, and you'll go into installing this package. What happens when you install it? Let's install Rotkey, for example. There's also the Rotkey team around here, and it'll be slightly less configuration. So you see that it's starting to download. Where is it downloading from? It downloads from IPFS, on which you also have a node inside of the dApp node. So you actually never have to connect to a server that we control. You just need to read the blockchain and read IPFS, and you're basically downloading all the software that you want. So kind of neat, but this also allows us to do one particular thing. It is when the package developer, when the app developer, the dApp developer, pushes an update of the dApp itself, your dApp node is constantly monitoring for events in the blockchain, and it says like, hey, there's an update. And hey, this is the IPFS hash. So if you allow him, it's always opt-in. If you allow him, it will download this package for you, and it will install it without any action that you need to take. And this sounds like kind of like, okay, my phone updates all the time. My laptop updates all the time. But this is managed in a completely decentralized way, without Apple pushing an update or without anybody pushing it, all through completely decentralized networks. And I think that's kind of cool. It's kind of cool for two reasons. Because maintaining Web3 infrastructure has always been traditionally quite a pain in the ass. It's an industry that moves very, very fast. You're constantly updating new versions. You're doing there's breaking changes. You're pushing hot fixes, et cetera, et cetera. It's kind of hard. And if you're a network, I'm not talking from the point of view of the user right now. If you're a network and you fucked up something on your last release, and you've discovered that there's a gigantic disaster waiting to happen, you can just push a new update. And it's almost like a decentralized DevOps mechanism where most people that are using dApp nodes, they will automatically upgrade to the new version, the new fixed version, without you having to chase every single node operator like, hey, you have to upgrade, we have like a protocol problem, etc. So it's kind of neat. For the user, I don't have to say it, it's amazing. I don't even have to go to my dApp node and just boom, I'm always in the last version. Like, oh, there's a hard fork, everybody update your nodes. I updated 2 weeks ago. What are you talking about? Like my dApp node outdated for me. I didn't have to take care of anything. Okay, so now you guys know what dApp node is. so we can close DappNode. Because we're not here to talk about DappNodes. We're here to talk about these little babies, these little machines, and how we don't need them anymore. No, I'm joking. We need them. Why do we need them? Why is it important that people run software, not these particular machines, but that you run this in your home? No one can turn it off for you. No one, huh? Resilience, that's exactly right. So resilience, no one can, like decentralization, but you know, decentralization is a spectrum where different properties emerge. What does this mean? It means that I can have a system that is completely Byzantine fault tolerant. It's the most perfect, well-designed distributed database in the universe, but I only have one node. Does it matter that it's Byzantine fault tolerance? Fuck no. It doesn't, like, you only have one node, so if this node goes down, the whole system goes down. You get 2 nodes. Oh, you get a little bit of data redundancy. That's great. You have 3 nodes, but they're in different countries. Okay, so maybe if somebody wants to shut down your network, and it's, let's say, a government, maybe having in 3 different jurisdictions is useful. So you get, actually, you get geopolitical resilience. Maybe those nodes are in different power grids. This means that you get resistance to outages, resistance to natural disasters in these regions. And you can see how this is a spectrum, right? Decentralization itself, and there's a lot of confusion here about, like, what is decentralization? Well, it's a spectrum where different properties emerge. You didn't come here for the philosophical talk, huh? But, well, here you have it. Other points on decentralization, what if there's a 0-day exploit in a particular type of hardware, in an Intel NUC? Well, it's good to have decentralization on the type of hardware that you're running as well. What if there is a 0-day exploit on the Golang compiler? Well, you better not have an entire network running on Geth. Maybe you want other types of languages. Sorry. So, again, all of this to say, decentralization, a spectrum where different properties of resilience emerge. Okay. This is why it's important that you guys run it at home. Because running home staking or node running at home is probably like the gold standard of decentralization, because it doesn't, like, it requires a very, very low barrier of entry. This might seem like a fairly steep amount of money, but you can just build it yourself. You can use an old laptop. You're paying for convenience here and to support the free open source software development as well. And because you're in different countries, you're in different places, so you need to run all this stuff. But sometimes we do not have a house, we're nomadic. Sometimes we need to switch houses, and we need to have our machine down for a few days or weeks, or sometimes there's a catastrophe happening and our DApp node breaks down and we need to buy a new machine, and this machine needs to have, where am I going with this? Well, sometimes it's okay to put your DApp node in a cloud. And this is very important. This is a lot better than putting it in a cloud, having it in your own home. Why? Because of this spectrum of decentralization that we've spoken about. But it's okay to put your validators on the cloud, especially if you don't want to lose money, if you don't want to be if you don't want to have a lot of inactivity leak while your validator is offline. So, after years of popular demand asking for how can I put my validator on the cloud in the easiest possible way, we have DappNode on AWS. Now, I know what you're going to say. You're going to say, Paul, you are always talking that all the nodes in AWS, if AWS goes down, if AWS bans crypto, you're going to be screwed. Yes, absolutely. That's why I'm saying, do it at home. And it's also not economically feasible for you to run a few validators on AWS. It's just going to cost you a lot of money. So do it at home. But if you need to, here's how you can do it without any command line. Excited? It's the most exciting thing you've done today. Come on! Okay, so we're going to go to Amazon Marketplace. AWS, not the marketplace of the things that you buy, not the Amazon Prime and all of these Fallout TV shows that you're watching and you're binging on. You're going to go to the AWS marketplace and you're going to search for DappNode. Cool. There's two versions. One that's going to cost you $15 an hour, so don't recommend that one. And the other one is going to cost you $15 a month. So obviously this first one is a mistake, right? Don't do that. So you just go to this one here, and that's what's going to cost you per hour. So it's pretty reasonable. Again, how many validators do you need to run on Gnosis Chain or Ethereum for you to make more than 0.35 cents per hour? Well, it has to make sense, right? This is why it doesn't really make sense to run it on the cloud, and you're a lot better off buying a 2,000 euros machine, which in Ethereum you can make in three or 4 months. Well, that's the price it is right now, maybe 3. But you break even a lot faster than this, okay? So, continue to subscribe, easy peasy, and you think, do we really need accept terms? Do we need a workshop for this? And it's like, yes, because even if you are tech pros and you know AWS like the back of your hand, it might not be that easy for everybody to run this in AWS, and especially if you don't know how to use SSH and go into your instances, and you're just like a hacker pro and going SSH into your machines, into your Amazon instances all the time. So we came up with a way of doing it without any SSH, any IP messing, in a way that you're going to get your WireGuard credentials to go into your Dapp node without ever touching command line. And yes, this is one of our North Stars. We want DappNode to be the extreme facilitator for UX, for normal people, for everybody to be able to run nodes without having to learn shit that is honestly, not for you, of course, but for some people, kind of scary. And they don't have to learn. Like the same way most of us will never know how to do tap dancing. Let tap dancers do tap dancing, and let us do the SSH stuff. But we need something for the tap dancers to run nodes as well, okay? So now you'll have to wait 6 hours until the configuration gets accepted. No, I'm joking. I hope not. Didn't know that I had to subscribe to this software. Okay, any questions so far? On decentralization, on DappNode, on AWS?
So how does this, once you deploy this, how does it actually work? Is it only one virtual machine, or does it also include firewall services or whatnot from AWS to close it down even further?
Yes, that's a really good question. You can configure all of this. We're going to see the steps for configuration later on. It's basically Elastic Cloud, and there's a few things that you can do. You can encrypt the disk, you cannot, you can add extra services. By default, none of this is configurable from the AMI side. We take care of everything that's Ubuntu. So for example, you'll have a firewall, the UFW, you'll have all the stuff that is in Ubuntu by default, but things like disk encryption or things that have to do more on like the virtualization that the Elastic Cloud uses, that you can configure through the Elastic Cloud platform. Yay! Okay, so we can continue the configuration, and that's what we want. We want a Dapp node, and that's what's going to cost us. It's going to cost us if we use this, it's going to cost us like a fuck ton a month. Maybe we just want a cheaper one, eh? We can choose. I think, oh yeah, we can configure it later. So that's estimated if we use M1 extra large, that's going to cost us a lot of money. So we're going to try to choose a cheaper one. And here, we just from now we just like continue, continue, continue. And here it's very important that we go through launching it through Elastic Cloud. And you'll see why in a second. We will need to input some user data in these fields, so we don't have to do the SSH stuff. Like if we do it through the website, it would start the instance, it'll give us an IP, and then we will have to SSH into it, and DappNode will be pre-installed in that one. But that's, I mean, you can do that anytime. You can probably do that on Hetzner, on a VPS that you buy, or like a bare metal Hetzner robot has like fairly okay machines for 50 euros a month, more or less. And if you know how to install DappNode on it, you can install it with the script. It's what I do. I have like a couple of DappNodes like this, and that works. But remember that we're trying to do like something where I don't need to install anything. It's just like pre-installed for me, and I just need to follow a few instructions, and we're good to go. So, name, test, DappNode. There's a good use case for a DappNode, for example, for a DappNode in the cloud. The main one would be, let's get a cheaper one. The main would be, hey, I'm running 64 Gnosis chain validators, and my DappNode broke down. I ordered a new NVMe disk, but it will take 4 to 5 days to come. I don't want to be down during these days. I can spin up something like this, and I can have my DappNode over there, keep validating, and then go back, change the key stores again and put them back in my actual physical hardware. So let's just go run around this. Let's go the T2 extra large, for example. Hey. Well, you know, fuck it. It's M1 extra large it is. So if you want to log in by SSH, you'll need to configure your key pair. This is what we're going to skip. I'm going to put it so I can show you what's happening in the back end. We're going to enter through SSH. I'm going to show you what's happening in the background. But a normal user wouldn't necessarily have to do that, create a key pair that they have on AWS, etc. So they'll just scroll down. Storage will put 30 because that's the free one. There we go. So does it fit a Gnosis chain node in 30 gigabytes? No, it doesn't. So you'll need to add a volume if you want to run more stuff. But for now, we're just testing here. So a very good use case for this as well, where you need a small disk, is if you use DVT, for example. If you want to distribute your validators using DVT technology. Because you can install DappNode in here, and you actually don't need to run a full node, a full Gnosis chain or a full Ethereum node, and you can just have a very lightweight OBOL instance or SSV instance and connect this OBOL instance with the main node or the other nodes that are physically running on a DVT setup. So let's say that you're running in a cluster and you don't want to be the laggard of that cluster. So just do this while your machine is getting back into place, connect to somebody else's full node, and you're good to go. Again, advanced details, and we're going to scroll all the way down. And here, in this field, we need to put two things. Remember, the objective of all of this, what it is? To never have to use command line. So what are we going to do to get the credentials to get into our DappNode without command line? We're going to use Telegram. The main thing for us was to keep privacy for the user. We don't want to know anything. And we definitely do not want to create these WireGuard credentials for you and give them to you, because then we would have access to these credentials, and we would have access to your DappNode. And if you put any private keys in there, we would have access to this private key. So no, we don't want that. And that's why you'll need to create a channel with a bot in Telegram. So anybody knows how to create a bot in Telegram? It is a lot easier than you think. there's a bot in Telegram called BotFather. And you just need to say new bot. All right, how do we call it? And we're gonna call it DappNode WireGuard test. And then it's gonna tell me, oh, you give the user a username, and it's gonna be DappNode WireGuard test bot. Boom. Oh. It's already taken. I want to avoid doing it that long, but hey, here we are. Do not tell me this is taken. Oh, here we are. Okay, cool. So now we're going to give our AWS instance, or our script that we're going to be running in our own AWS instance, we're going to give them this token so they can post messages into a Telegram chat with ourselves. So we're just going to copy this. I'm just going to keep it safe somewhere. Okay. And then we also need our Telegram ID. You can get your Telegram ID by messaging a few bots that have this. One is raw_data_bot. You message this with /start, and it'll give you your user ID. So if this is a lot of steps, don't worry. There's going to be instructions for you to follow later on. So I am not going to show my. I'm not going to show my Telegram user ID. So I'm just going to be. Some of you guys spamming. So I'm going to be putting this on the other side. Tuk, 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 tuk. Here we are. And I'm going to go with comma separated. Comma separated the token and our user ID in this way. I'm going to go back here. My user ID is not XXXX, so I'm going to change it now. But I'm just going to put my user ID here that I got from the other bot. And then I'm going to go back. Tack, 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 tack. I'm going to put my real user ID now. And comma separated, and then we're going to go launch instance. It's just a button over there, and we're launching the instance. Cool. Now, instance initiated. Remember that we actually did put the SSH, so we're going to try to SSH into this place. Click on the instance. This is my public IP. Okay. Da, 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 da. And boom, I'm here. So now let's see if DappNode has started. This is something that the user will, so put a parenthesis here. You as a user doesn't need to do that because the whole point is that you don't need to enter through SSH. I just want to show you that DappNode is starting on this instance, and slowly we're going to be upping up the containers. And when the WireGuard container has been up for a couple of minutes, then we can message the bot. So uh-oh. There's no containers. Well, that sucks. Compulsively putting Docker PS. Okay, so that didn't work. I do not know why. Sad moments for this. Cool. Let's see. Well, we know that it's not going to work because there's no Docker containers running. But what we would do is we'd go to botfather, and we would go to the bot that we have created, which is dappnode WireGuard test.bot. No messages here. We would start this. And we just write WireGuard credentials. But nothing's happening because it's dead. There's nothing, which is very sad. And what we could do right now is we could do the same thing with the AMI that costs $15 an hour. The obvious mistake, because that's the one that I used yesterday and it was working. So there's going to be a problem with this AMI. That's what happens when you do things the day before and it didn't work. So I think you guys get the idea. But if you want, we can do it with the other one. But basically, what would you need to do is it would give you WireGuard credentials that would be like that. They would give you WireGuard credentials that would be like this. We can connect here. It would be the exact same would be happening that if you go to VPN right here, and you go to WireGuard, and you add a device. Oh, you need to add a name, and it would be failed test. And then we would add a device. These are all the people that have access to my DappNode. That's a fuck ton of people. Then adding failed test, no worries. That's the second failed test that we add today. And it will create WireGuard credentials. I mean, we can use this ones already that I already created. It takes a while because it needs to create private keys, and cryptography takes a bit. Goodness gracious. Adding failed test. Oh, failed test is added. Good. Get link. It's not working either. Okay, guys. It's not our day today. Bueno. So we're going to add a third failed test. And here, you just get this QR code. You can scan this QR code, put it on your TunnelBleak or OpenVPN client, and you'd be able to have access to my DappNode. And this is pretty much what would happen with your Telegram. You would be sent this, you'd be sent WireGuard credentials that you would add, and you would be able to access the DappNode by putting these credentials into your client. Let's give it a last try, see if any Docker containers have started. Hey. Saved by that fucking bell. I did not have it in me. I thought it was not gonna happen, guys. I'm not gonna lie to you. I thought this was not happening. Okay, so it did happen. It's been running for a while now. All of these are the DappNode containers. And now we can go to Telegram. And wait a minute. Okay. So we are going to at this point you already believe me, but that it's going to work. But I just want to show it to you. Because you believe me it's going to work, right? You do, right? Oops. Pero bueno. There you go. Get WireGuard credentials. And here we are. Those are the WireGuard credentials for this DappNode instance that we have set in AWS. So, what do we do now? We go to our WireGuard client, go to Manage Tunnels. We add these WireGuard credentials in here. We're going to disconnect here. Boom, add empty tunnel. We're going to create those. Boom. Oh, I don't see. Yeah, here we go. Save. Oh, sorry. AOS DappNode. Yeah. Save it. Start it. Activating. It's active. So at this point, we wouldn't even know the IP of this, right? Like, probably we'd have no idea. We wouldn't have to have any idea. And but we should be able to connect to our DappNode. Now, it took so long to start the Docker PS that I don't know how this is going to take. Oh, goodness gracious. And everything that can go wrong will go wrong on a live demo. So, guys, here's the trick. Whenever you have to do a live demo, just record a video. And just explain the video. Just pretend that you're typing, but in reality you're just pausing the video and putting it back again. Okay, let's see what's happening here. Okay. Here we are. All tunnels are now active. Well, not all tunnels are now active. No, this one. And voila, that's it. I'm giving up. So, in theory, DappNode is running here. In theory, we have WireGuard credentials that would allow us to connect to this DappNode. But then you don't. But you should be able to. And this will be more polished by the time you guys try to do it on AWS. Now, questions. How do you connect? Well, WireGuard. Do you know?
Pretty cool demo. first of all, except for the last part.
Thanks.
Have you considered using something other than Telegram for delivering the supposedly private credentials?
Oh, like what?
Some other messenger.
Oh,
Matrix, whatever.
It really does not matter. I think the main idea is that you need to give the instance something to send you a message without DappNode or us intermediating. We used Telegram because you can give him the API of a bot, and then it can talk through the voice of that bot. And that means that the DappNode team does never know the WireGuard credentials, and we can never access your DappNode. This was the main thing, that we don't create these WireGuard credentials for you, so we can never access this. It could be done by Matrix in a very similar way. You just give him you spin up a Matrix instance in the DappNode itself, and then you send a message to your username from the DappNode itself. It could be done this way. Maybe it will be done this way when we add more options, but as you can see, it's fucking half-baked. So, there's a lot of room for improvement there, including different ways of adding.
Okay, second question. Have you ever considered adding something like a premium or supporter monthly recurring fee? Not sure how you would attach or what features you would attach to that, but is that something you have ever considered? Is that out of the picture for
Yes, yes, absolutely. I think there is something on the way. There is so we have a free tier of what we call the ethical metrics, and ethical metrics is basically when we, as you have seen, as sort of like one of our design principles is to really preserve the privacy of the users and never exploit their data. And we are very wary of not even having access to data for our users. So this ethical metrics thing, it basically allows us to be able to tell you that your DappNode is down without us even knowing where your DappNode is. And how do we do that? We basically spin up a Tor hidden service in your DappNode, and we send this metric, we send these pings of liveness through the Tor network. So our server can receive these pings of liveness, like, okay, DappNode identified as a random string of numbers is online, good. And if we don't receive these pings, we can send you an email or a Telegram message to the email that you have attached in the message and say, hey, when you registered this, and say, hey, your DappNode is down. And we did this because when we created DappNode, we had self-sovereignty as like one of our main things in privacy. And people were like, oh, but how do I know if my DappNode is down? And we didn't have any solution for them because when your DappNode is down, your DappNode cannot tell you that it's down because it's down. So we figure out this way. And we capture several metrics there. We could capture metrics on like your performance, the performance of your validators, the performance of your validators considering the bandwidth that you have. So once you start giving metrics for this, maybe a premium service is not only alerts for when your DappNode is down, but also maybe like a monthly tip about how to improve your performance on attestations, on validations, maybe even include insurance. We've been talking with a few insurance companies that insure against like slashing and inactivity leak and all this stuff. So maybe DappNode Premium would include some sort of insurance for this. So maybe like Rodkey, for example, who has Rodkey Premium as well, make some features, paid features. It has even the dark mode as a premium feature, where the dark mode will be free and always. Mark my words, friends. Dark mode on DappNode will be free and always free for all the DappNode users. I don't think it's that important of a feature, but people get really upset about dark mode. So yeah, so a lot of these features, a lot of this stuff, especially what I think is most important for a DappNode Premium is a premium line of support. So DappNode is free open source software. And a lot of people use DappNode, and we don't know because we don't capture any telemetry. And our Discord has a lot of support. And sometimes our devs are kind of busy, and maybe they cannot answer immediately. So a DappNode Premium sort of thing would give you a more direct line to faster support. Why didn't it work? Exactly why? Why? Sorry.
Have you done the math for how many validators this makes sense for?
It doesn't make sense. So it's going back to the DappNode Premium Premium situation. I think a very good use case for this is, so first of all, it can make sense. Of course it makes sense. Why do we know that it makes sense? Because AWS is where most of Ethereum's validators run. But you're not running one, you're running thousands of validators, okay? But infrastructure costs are high. But let me tell you when it makes sense. In the case of a DappNode Premium, we would have an authenticated node, the full node, that you can connect your validator, and you would only need to run your Web3 signer on this cloud server that you completely control, and we give you access to this full node, and you only connect the Web3 signer to the full node. So you have virtually very, very little, the time that we took to spin up this node, which hopefully it'll be a lot more, it'll be a lot faster, and with less problems. But that's how much time you would need to be down before you can just even try to figure out what happened to your main node. We'd just give you this, and you'd be able to run this.
The costs don't like necessarily scale with the number of validators, right? So like once you have like 5 or 6 validators, it seems like it would make sense.
It depends on the instance. So we've used instances that do not have big volumes. Volumes meaning the disk. If you need to run a full node yourself, AWS is very expensive. You're much better off going to Hetzner, going to OVH, going to even Contabo. Whenever you have you ever used Contabo?
No. What's it?
But you can. It's cheap. It's cheap as fuck. But I wouldn't put a validator there. You're much better off. And then it breaks sense as long as you get like more than, I think the cheapest one is 34 euros a month. So I haven't done the math. So I don't know how many validators that is, but probably like 3, 4 or something like that.
Okay. My second question, I have. Once you set this up on the cloud, like say I have 32 ETH right now, I want to set up DappNode, but I'm not ready to set up the hardware. Can I set up the hardware and easily migrate it later?
Oh yeah, absolutely. Yeah. The main thing here is that you always exits are enabled, so no problem. So you can exit your validators at any point. So if this is not for you, you just exit the validators, you're good to go. And if you decide that it is indeed for you, you just need to move the key stores from one setup to the other setup. And this flexibility for just moving the key stores from one to the other, and the fact that these setups look exactly the same, the UI that you get served from your machine at home and the UI that you get served, or not, from the machine on the cloud, they're exactly the same. So you don't need to get used to different systems, et cetera, et cetera. So very transportable from one to another. Now, things to bear in mind, this is dangerous. Do not even think about backups. Do not think about backups. Do not. Why? Because if your DappNode is down and you start a DappNode on the cloud and you put your key stores over there, and your mom brooming touches the button of on and your DappNode turns on again and the key stores are still there, you're going to be signing in 2 places. And that's a lot worse than being offline. That's a slashing condition. You're going to be forcefully exited from the validator set, and you're going to get slashed. Being offline, as Chuy said before, being offline does not get you slashed. It has inactivity leak, which is about, Nick's correct me if the numbers, but it's about half of what you would have earned. So if you earn 1 per attestation, you lose 0.5 per attestation, which means that if you are offline for 2 weeks, in 1 week, you're back where you started. So on the big scheme of life, doesn't really matter that much if to be offline a little bit. But if you get slashed, that matters a lot. You're going to lose a lot more ETH. So this is not a good setup for backups. You don't need backups as a solo staker.
So coming back to the what you talked about, the premium features or possible premium.
You just want to give us money, don't you? You just want to pay for. That's great.
But what I see, not often, but with a few DappNode users, is obviously they don't know anything about hardware, right?
Yes.
That's the reason why you buy DappNode in the first place.
Yes.
So there's often improvement potential in the setup they're running. Possibly configuration of the packages, or even file system, whatever configuration. Maybe even the SSD is dying or whatever. So all of that stuff is beyond their competence level. So I see this as a great opportunity because before things go south, you can actually already see that things are bad.
Yeah.
And that's where I see opportunity to actually provide very good insight and help people while they're already running DappNode, because otherwise your only touch point is at the sale.
Yeah, absolutely. I think one of the things that's happening a lot is that people put their DappNodes like under a table or in a cupboard with no ventilation at all, and for some reason, it just accumulates dust, the fan gets full of dust, and it cannot ventilate properly, and the temperature goes up, and this is bound to end up breaking your hardware. It's just going to shut down at some point. So if we detect that for a few days your temperature has been constantly high and it does not go down, we could just go like, hey, we've noticed that your DappNode is pretty hot all the time. Are you sure that you have it in a well-ventilated place? Are you sure that you do something like this? So this type of preventive measures would be extremely, extremely good. This is a really good point. All right, it seems like we're good to go. Last minute questions? No? All good? Perfect. Well, guys, thank you very much for learning how to spin up a node on AWS and for taking a leap of faith that at some point you'll be able to, not that you have seen it happening. But yeah, I mean, it was only the last step that didn't work, right? So thank you very much.
All right. Thanks everyone for joining in and attending the talk. I'm Raphael. I'm leading product and growth at Arrakis. Arrakis is a decentralized market making protocol. And today I'm here to talk to you about HOT AMM, which is an MEV over design for new AMM. Arrakis designed this AMM with Valantis together in cooperation. And we will be launching this new type of a DEX very soon. So this is really exciting for us today. This is the first public talk about HOT. And HOT is a creation that is a reaction on what we observe in the entire on-chain trading. And we do a lot of research. We look a lot at order flow. And one thing that we noticed in the last month and sort of like the last year is this increasing importance of private market makers. And they are capturing more and more of the intent order flow. And with HOT, we want to react to this and provide an alternative source of liquidity. But before we jump into HOT, I want to go back and actually start at the beginning. Why are we trading on chain? Like if you want to trade digital assets, you have three different options. Basically, you can trade them on a centralized exchange, you can trade them on a decentralized exchange, and you can trade them on so-called hybrid exchange. So with regards, if you look there in these three worlds, if you look at the different dimensions, liquidity, trade settlement, custody, and market making, what we notice is when it comes to liquidity, a centralized exchange has off-chain central limit order books where takers and makers meet each other, and it's all settled off-chain. With hybrid exchanges, we've seen many different forms, but it's mainly still off-chain central limit order books, some sort of like solver auction, relatively new designs there that have come up. And we see the decentralized exchanges where we have a liquidity pool, so actual LP providing liquidity. With regards to trade settlement, we see that centralized exchanges, they settle all the trades off-chain. Hybrid exchanges and decentralized exchanges, they settle them on-chain. In custody, we see the so-called omnibus wallets on centralized exchanges, but then we actually have self-custody for traders on a hybrid exchange, and with things happening in 2022 with FTX, self-custody becoming really important. So sort of like those hybrid exchanges and decentralized exchanges have become more favorable for traders. For us as a market maker at Arrakis, the market making side is really important. And we see that in a centralized exchange, there's centralized market makers. So all the parties also providing the maker quotes in the order book, they're all centralized. Well, then in a hybrid exchange, we still, in many cases, see a centralized maker like a solver, which is a centralized party. But we actually have a decentralized taker. And then you have the DEX, where actually both the liquidity provider, the maker, and the taker, both of them are decentralized. And with HOT, we try to bring in the best of the two worlds of a DEX and of a hybrid exchange, and actually bring them together and try to overcome the weaknesses of an AMM. So looking a little bit back at the history of AMMs, what is actually the objective of an AMM? Here we have two objectives mainly. One is price discovery, so actually finding the right price for the asset. And this is largely happening by an arbitrageur coming in and bringing in outside price information, most likely from a centralized exchange, and updating the so-called stale price in the AMM. And at the other side is bringing in liquidity from all sort of liquidity providers and actually centralizing this liquidity so that you and me also as retail participants can provide liquidity, but also institutional liquidity providers can come in and give liquidity to the market. So the evolution of the automated market makers, so the AMM, has seen different forms of basically math behind the scenes. And an AMM started off with this constant function AMM. This means you have x times y equals k. X is the amount of one asset, and y is the amount of the other asset. And then this is always equal to k. those sort of like were the initial like Uniswap developments, like anything around Uniswap v1, Uniswap v2, where you basically provide liquidity from 0 to infinity, also called like a uniform uniform liquidity distribution. And providing liquidity from 0 to infinity for almost all assets is not really efficient because you provide liquidity in price ranges where there's no trading activity happening. So another concept was developed called concentrated liquidity AMM, and UniV3 was one of the first ones launching this, where you actually provide liquidity in a specific range. So you can provide liquidity across certain price ranges, and then you can rebalance those ranges to have more form of a concentrated liquidity, and this is much more capital efficient. However, still as a liquidity provider in a concentrated liquidity AMM, you face the so-called term impermanent loss or LVR. So if the inventory that you provide basically changes in price, there's volatility, you have to face some sort of loss, and you have to make sure that your trading fees are actually larger than this loss. So a lot of new AMM designs and new DEX designs try to reduce this so-called LVR, and also HOT goes into that direction. So resuming again the motivation for change, we're coming from this constant product AMM, where we really had like an inefficient capital allocation, and we're moving towards the right to get actually more capital efficiency. So the motivation between constant product to move to concentrated liquidity is really to like get active liquidity, and now the liquidity providers actually have non-fungible positions. In like a constant product AMM, usually all the liquidity providers have like the same position, while now in a concentrated liquidity AMM, everyone has their own specified liquidity position in the AMM. And then all the new AMM designs we've seen recently, and CowSwap, I see the guys there, thanks for joining. It's basically one of the designs, but there are many more designs, and I want to spend the rest of the talk basically to go over HOT and explain more why HOT AMM, like hybrid order type AMM, is a solution for this. So HOT AMM has 3 main objectives. First objective is LVR protection. So we're trying to protect the liquidity providers via an RFQ order flow. We still want to preserve this permissionless, trustless DEX design and provide the traditional swap AMM for mainly targeted at retail traders so that everyone can come in and trade at HOT. And then we have this permissioned Arrakis quoting service that actually enables dynamic fee updates. So these were the 3 main objectives when designing HOT AMM. Looking behind the scenes, what happens in HOT is that on the one side we have this solver type order flow. So this comes via flash swaps and actually brings in like solvers competing for quotes. So solvers come in and compete for prices, and they bring in price updates and updates to our dynamic fee schedule. And at the same time, it brings in the benefit that the entire like LPs in the pool get additional non-toxic order flow, because to be a solver on HOT, you have to be a trusted party. So not everyone. It's basically a permissioned order flow. And then at the same time, we still have a regular AMM design, very similar to concentrated liquidity, where retail essentially receives better AMM prices because solvers are competing for prices and they're frequently updating. And our objective is that in an AMM, no longer arbitrageurs are updating the price, but solvers competing for price updates and bringing in the best information are updating then the AMM stale price. And at the same time, we introduce dynamic fees that protect LPs from LVR, because with the time in the block and AMMs are limited by the block time, we basically increase the fees for swaps. And thereby, at the beginning, we can bring in rather low fees, but then they're increasing, and we create this dynamically rising no trade zone, essentially trying to avoid arbitrage being profitable. Looking at these dynamic fees, and there's a really nice graph there on the left. I hope you can see it, and it's not too small, but it basically shows on the x-axis the time, and then you have the price on the y-axis, and then basically the lines that are drawn there, that's the price, the stale price in the AMM, and then you have the centralized exchange price moving, but every time this line sort of breaks, this is when the price is updated. This is when a solver comes in and quotes a new price, and at the same time, like you have the block times on the x-axis, we can actually update always the price on top of the block. So this means the longer we are without an update, the longer we are waiting for another solver coming in, updating the price, the higher is the dynamic fee. And that means that we are trying to capture, this arbitrage and reduce the arbitrage possible. You can see in some situations there will still be arbitrage possible. So if the centralized exchange price goes out of this no trade zone, then actually there will be arbitrage, and therefore we're trying to minimize it. And essentially, like, if you look at the equation on the right, we want to protect LPs by always ensuring in as many cases as possible that the trading fee is actually larger than the difference in prices between a centralized exchange and a decentralized exchange. By having this feature, we're actually able that on average, the minimum hot trading fee is likely to be lower than the regular AMM fee, because an AMM, traditional AMM, just quotes like a standard fee for all retail flow, while here on hot we can actually have dynamic fees, and we only quote higher fees if it's really necessary to protect against arbitrage. This was a really brief excursus on hot. We haven't launched yet. We will be launching this soon. We're really excited about this. Obviously, it's only one attempt to solve this problem. There are many more. But I'd like to summarize our perspective on the entire market from the research we're doing. And we think that the market will move towards many different DEX designs. Like, while the past has been rather like, we started off with this uniform liquidity, moved to concentrated liquidity, and now sort of we are breaking out of this by many people finding different ways of designing better AMMs. We think there are different solutions. Dynamic fees is a very good solution to protect against arbitrage, but you can also, for example, integrate off-chain price information, like bringing in information from centralized exchanges, various ways to do this. We also think request for quote, so like actually this entire solver searcher type quoting mechanism is really a good way to solve problems in the AMM space. And it means essentially that you have to discriminate traders and order flow to make sure that you avoid toxic order flow reaching your liquidity. And in-protocol auctions are also likely, possibility that you can choose, or a way to choose to avoid, arbitrage. Oh, no, flipped too quickly. Quickly talking about Arrakis, so you might know Arrakis as this automated liquidity manager, but Arrakis is more than this. Arrakis is a decentralized, permissionless, on-chain market maker. We focus on two sectors. On the one hand, we're building out infrastructure. So we're an infrastructure protocol. Hot AMM is one of the solutions or products that we will be launching to the market soon. And we try to bring in innovation to the entire DEX and market making sphere. And at the same time, we're serving algorithmic strategies to our clients, being the DAOs and labs and teams raising money via tokens, launching tokens, but also providing sustainable liquidity providing strategies. So that marks the end. I'm happy to take any questions up front. And thanks for attending. And yeah, hope you get excited about HOT, and feel free to follow Arrakis at Finance on yeah, Twitter and Telegram. We will be posting updates soon. There's also our research paper about HOT AMM was released a couple of weeks ago. So if you want to dive into detail, the paper is public. You can read up on this.
Thank you for the talk. What part of the benefit of your protocol comes from things like the dynamic pricing versus stuff that you cannot do without basically being hybrid in a way?
So the hybrid part is really the solver order flow. So interacting with trusted parties which are permissioned to access liquidity. And that brings in the price information and sort of segregates the order flow. And we can make sure that from solvers, we only get non-toxic order flow for updating our prices. So this is really for bringing in price updates. Instead of relying on arbitrageurs, we want to rely on solvers to update the price. The dynamic fees is a measure of reducing arbitrage while we're waiting for the next solver to give us this new price update.
I meant in terms quantitatively, if you basically
Mm-hmm.
have the benefit into percentage.
It's hard to quantify before you launch it, I would say. Let's see. Yeah, like we will be launching this soon, and then we can definitely measure this. But right now, it would be pure guess, I would say.
If there's only your hot AMM for a specific liquidity source, is it possible that it basically gets stuck? Because if the fees increase for trading on the pool, there's like, and it's the only liquidity source, could it be that nobody is like incentivized to like settle any arbitrage like trades for a specific token, for example?
Good thought. I mean, essentially would need to have a solver coming in to provide price updates if we solely rely on this. Otherwise, the price would basically stay there, and then the fees would be increasing. I think HOT really is a solution first for like more liquid assets. And we're not planning to launch like tokens which are very illiquid and not trading elsewhere. I think initially we'll be starting with tokens that are more common and tradable at other venues.
So would you? I'm not sure if you try to project or throw some numbers at it, but would you then expect the dynamic fee increase to then ultimately benefit liquidity providers as arbitrageurs come in and try to bring the price equilibrium into the model? And is that the intention then, to benefit LPs over users?
Yeah, so the intent is to benefit LPs by you have this increasing fees on the traditional AMM, and thereby it gets less and less profitable for someone exploiting this and doing actually an arbitrage. Because this AMM, like the right side in the diagram, is actually permissionless. Everyone can come and everyone can ARB into this pool. So you have dynamic fees while we're still stuck with a stale price. People could come in and actually ARB the pool. Because we have to wait until a solver reaches our liquidity and provides this new price update, and then actually can reset the fees. Because with a solver, we have a trusted party where we know this is actually the true price from an external venue. And thereby, like, we aim at increasing this no trade zone so that actually no toxic order flow can reach our liquidity. But at the same time, obviously, also compensate the liquidity should someone come in and actually trade against the liquidity.
Okay, sure.
Yeah.
I would have a question regarding the user perspective.
like if the fees are dynamic, would there, and there are these large no trade zones, how you call them, would there be like longer times where it doesn't make sense for a user to trade on hot DEX and rather use, let's say, a DEX aggregator, because otherwise you would always need to keep track of the dynamic prices and prices somewhere else, and you may get a very bad deal because the no trade zone is quite big.
So ideally, from a user perspective, you come via intent-based trading, and then you have a solver basically filling your trade. That's the one side. If you interact with the AMM, sort of like, obviously the fees will be rising, so it makes sense you can then quote also like what price you want to settle against. And then you basically can trade after an update, right? So you can wait, and in an ideal world, these updates will be very frequent. So ideally, we get an update from a solver every few blocks, and then we will not reach this territory where prices, or like where the trading fees are actually surpassing a traditional AMM fee. It's just like this traditional AMM cannot react with its prices, so it basically needs to charge a certain price, and you see like more volatile pairs being on like higher fee tiers than like stable tokens or stake packed assets, and there you already have lower fee tiers. For us, what we want to achieve is that the average trading fee that the user, like the retail user, gets is actually below a traditional AMM.
Yeah, makes sense. Thanks.
Thank you.
With Uniswap at the moment, if there's a fixed amount of liquidity, as the price moves, the depth changes. Is that the same with this design, or as the price is updated, all the liquidity just for, say, one of the assets stays at the same depth, or does the depth change?
It's going to be the same. So the traditional AMM for accessible for everyone, like the permissionless AMM, that's going to be a concentrated liquidity AMM. And then this liquidity is also accessible for solvers. So we have sort of like this sovereignty where you can think of like it's a sort of like a pool with a hook where a solver can come in and actually also access this liquidity, where the competition of different solvers actually quoting for the best price and bringing in updates.
So as the solver updates the price, they're not actually taking assets out of the pool, it's just like an oracle. Okay.
Yeah, exactly. So they're trading against this liquidity by competing for the liquidity.
Okay, cool. Thanks.
Cool. Awesome. Thank you very much.
Great. Hi, guys. Thanks for coming. The last talk. I'll keep it kind of shortish, I hope. This is the first time I'm talking about this, so this is a tryout. I'm giving you a vertical slice of the liquidity market, showing where the complexity lies in, and to give you a better understanding on where we are at when it comes to this space. Okay, so let's start with describing the asset layer first. So we have L1s, L2s, and L3s to settle, execute, and scale. What we're typically minting here, and let's just talk about the liquid market, is essentially ERC20s, right? On top of that, we have messaging bridges. On the one hand, it's the canonical ones, like the native bridge that's being provided by the ecosystem. But we also have third-party messaging bridges, Layer 0, Axlar, Wormhole. And this is the point where we have to introduce additional standards when it comes to messaging. Because we are in a multi-chain environment, and in this multi-chain environment, we want to be able to have asset representations on multiple chains. And for that, we need some sort of accounting, right? We need the ability to mint and burn assets to make sure we don't have double spending, we don't have a duplicate creation of value. This is what Layer 0, Axlar, and Wormhole, and so on take care of. And they all want to establish their own standards, which makes it difficult to actually navigate the space. Now we have different asset representations. Actually, each OFT is its own bridge, makes it even harder. And similar scenarios for ITS, which is Axlar, NTT, which is Wormhole, and XRC20, which is a more bridge-agnostic standard, an attempt that's being created by Connext, which is an established liquidity network, and they are really concerned about standardization. And so if you're thinking about launching your token multi-chain, take a look at XRC20 in the first place, because you have less of a vendor locked in compared to other standards. Now, we have a bunch of assets. They all represent like fungible tokens. On top of these messaging bridges, we have liquidity networks. Either the direct native ones, again, I'll get to that, or we have third-party liquidity networks. So first of all, why do we have them? Messaging bridges allow us to send arbitrary data across chains. This means we have to check for a lot of things, and that data verification becomes expensive and comes with a great overhead. So when it comes to transferring value, we want to keep it as cheap and fast as possible. So instead of just minting and burning assets every time, let's just create liquidity pools on both chains and then have fast transfers across chains by simply sending, hey, I'm sending money on chain A to the liquidity pool on chain A, and then I'm releasing the same amount of money on the destination chain, deducted by a fee, but then send the money from the liquidity pool on the destination chain. This is more efficient in a sense that it goes faster. It's for the user, it's better. At the same time, it creates a capital efficiency problem, because now we need to have liquidity on each chain, right? Now, Layer 0 has their own one, Stargate, Axlar has their own one, Squid, and Wormhole has Portal and Mayan. So all these established AMBs, arbitrary data messaging bridges, have their own liquidity networks. On top of that, we have third-party liquidity networks again. So another player that allows us to move money, Connext, Hop, Seabridge, back then multi-chain. So there are a bunch of Synapse as one. There are all in all around 100 bridges out there. And this is just for you to understand. This is the lowest level. That's the lowest level of which assets can the user hold and trade with, and what is necessary to just understand how to navigate yourself in that multi-chain environment. On top of that, the user should understand the trust spectrum, because all these third-party bridges introduce different trust assumptions. I'm not going to go there. This is something that this could fill a whole talk. But this is something DeFi looks a lot at. It's essentially which trust assumptions are being made and where are these players on a spectrum. And that's why we integrate some bridges, and that's why we don't integrate some bridges. On top of that asset layer, we are getting to an exchange layer. Now we spoke about asset minting and moving across chains. From here on, we have the exchange layer, which is separated in two pillars. On the one pillar, we have the decentralized exchange layer, where we talk about DEXs and DEX aggregators. On the right-hand side, we see the centralized exchange layers. Here in the first place, we have centralized exchanges. We have players like market makers, OTC, and prop desks. And but I'll get to that. If you take a closer look, this again becomes very complex. We have so many different AMM designs, right? We have Uniswap v2, 3, 4. We have already heard in the last talk about concentrated versus range liquidity. We have concrete versus concentrated liquidity. We have multi-asset AMMs like a balancer. We have order book style like VX. We have stablecoin focused AMMs like Curve. Multi-chain DEXs, Catalyst launched just yesterday. So this is a multi-chain native DEX working with liquidity pools and price discovery across multiple chains. They are building on top of Wormhole, a totally new thing actually. And we constantly see new AMM innovation like Arrakis' new hot AMM or CowSwap as a coincidence of ones, which also includes like batch transactions and new ways to actually trade. And there are so many more. Like we are getting outreach every 2-3 weeks with a new AMM design that wants to make things better, and it's really hard to make all of that measurable, but I'll get to that at a later point. On the right side, RFQs, market makers, centralized exchanges, and another type of bridge, centralized exchange bridges. They do exist. LayerSwap was one of the first ones back then. Back then it meant for you as a user to generate your own API keys, create an account at LayerSwap, add your own API keys into it, and then you could bridge via centralized exchanges without having to use those exchanges. That has changed a lot. RocketX was then the first mover on creating some sort of centralized bridge, abstracting away all that API key management and moving liquidity around, and then LayerSwap copied that. So also there are alternative solutions, and it's very interesting to see what's coming. And what we are seeing now is that all of that becomes a bit more hybrid. Solver systems are coming up, intent systems are coming up. These solver systems, and right before we saw payment for order flow systems, are navigating trades across decentralized and centralized liquidity, depending on how sophisticated they are. The most established ones, to be fair, still are just on the decentralized spectrum, and we have payment for order flow that work systems that work more with market makers and prop desks, but this is merging, and on top of that, we are sitting with DeFi. With DeFi, we really try to aggregate everything. Also, be fair, again, here, right now, we are mostly focused on decentralized exchanges and decentralized liquidity across DEXs, DEX aggregators, bridges, and solvers. But via the solvers and payment for order flow systems we start aggregating, we are also getting access to centralized liquidity, which provides the best price. The question is, though, do we need all of that, right? Do we need all these different DEXs and DEX aggregators? This is the swap distribution across multiple DEXs on DeFi. So what we can see here is how are the swaps distributed across different solutions. And for example, while people mostly think about aggregators like 1inch and 0x and maybe PowerSwap still, there are players like Odas that outperform 1inch quite often, as we can see. This makes the case for aggregation just for exchanges, not even just bridges. I mean, when it comes to bridges, it's about pathfinding, like which bridge do I use to get from A to B. But when it comes to liquidity on just exchanges on one particular chain, is it worth it to aggregate DEX aggregators? Yes, it is. And now with the solver systems, it becomes even more relevant. And this is not on one chain. This is completely different on all these different chains. So on different chains, we have a different swap distribution just for DEXs. That again makes the case for aggregation. Aggregation of DEXs, DEX aggregators, and solvers. If you talk to a solver system why they outperform 1inch, then the answer is simply we have more liquidity sources than 1inch. Apparently, 1inch at some point stopped implementing new DEXs. They were just like, it doesn't scale for us, it's not worth it. But apparently it is worth it, because Odas now is growing very fast, gets lots of volume. There are other players like Propeller Hats, OTEX, Barter, and so on. Many of them mostly active on L1. But this is changing fast, and the solver market is a very interesting thing I'll also dive into. Now, we haven't spoken about that all of that takes building an aggregator or building a solver system that's sophisticated means addressing, understanding, implementing, maintaining, and monitoring hundreds of APIs. At least one RPC per chain. You want to have fail safety, so make it 2. You need guess estimations. They actually differ. it's totally different on one chain where they take into account the overall payload size versus on others where they don't. We have fee markets, so I have a DEX fee, I have a bridge fee, I have the gas fee, I have multiple chains. Transaction simulations become complex, and I need that, plus regulator networks to actually combine more complex transactions. So if I want to go from one asset A to any other asset X on chain B, I often need to swap, bridge, and swap. For the user, that's horrible, right? So with DeFi, for example, we make sure that we aggregate all of that, and we connect all of this on an on-chain transaction rail. So we can swap, bridge, and swap within one signature with our one transaction. And that's also necessary for the solvers. But transaction simulations kind of become a hellhole because there's gas slippage. Just that alone is annoying. And it becomes hard to make that fail safety. On top of that, we end up with lots of fragmented data. Each bridging transaction is not one transaction, it's two. It's one transaction on the source chain, it's one on the destination chain. So you have an additional analytics overhead, your BI, your internal business intelligence. It gets messy really quickly, and Dune is also not of a great help because Dune doesn't support these more complex multi-chain transactions in a great way. Then you have to combine that data with, for example, Flipside. You need additional data sources. Then you have different asset representations: USDC, USDCA, USDCE, wrapped USDC in different forms. This is just USDC. We have the same situation with DAI, USDT, now PiUSD, and other stablecoin alternatives are coming. It is a very messy situation we are in. And then getting back to the APIs, who does all the status code mapping? Do you think we are getting great API responses? Certainly not. To debug all of that is kind of hard. So status code and error code mapping, just in order to provide a good experience for developers and end users, is really tough. Yeah, fragmented data across the board. And now we just spoke about EVM, right? I don't need to tell you that non-EVM exponentially increases the complexity of this problem. DeFi is now 60 people almost. We are 60 people and we're still just aggregating. And I could double the team tomorrow and would still be busy. It's just so much work. And we don't see a near future, where we are getting out of that mess, because there are some people interested in standardization, but the best funded companies are not. They want to have a vendor login. And that's what they are pitching their VCs, to get huge valuations and raise a lot of money. Everyone wants to become the standard, so no one is interested in adopting the standard, right? We just saw Uniswap and Across trying to come up with a standard for cross-chain settlement, so that intents that are being fulfilled by UniX could be settled by Across. We'll see how many people are actually going to start to adopt that standard. And we still haven't talked about fail safety. If an RPC is not available, you need a second alternative for everything. We haven't spoken about high availability. If you want to serve a Robinhood, someone with millions of users, you need high availability because they otherwise want redundancy. And well, you kind of, as a solver or aggregator, you want to provide redundancy, right? But then what is your redundancy? So it gets difficult for someone that has to be compliant and needs to be available all the time. And then we have global availability. So then suddenly you realize that your API gets really slow in certain regions of the world, because just to realize, oh, actually 0x has their API only deployed in Europe and in the US, and in Singapore it's not, and then latency comes into play. So for global availability, you need another level of analytics just to understand, like, where are my counterparts, where are my third parties actually deployed, how reliable are they, and is it up to date? And we haven't started optimizing yet, right? Because then you want to optimize for API latency, but also for gas costs and all of that. Monitoring analytics, rate limits, and API costs, MEV protection, customer support. It is a very messy situation we are in. We are talking about mass adoption, we're talking about chain abstraction, but we're so far away from that is the reality. We're so far away from mass adoption. DeFi tries to tackle that. I don't want to talk too much about DeFi. We said 3 years ago, someone needs to aggregate that and abstract it away. And 3 years later, we have the narrative chain abstraction. Thank you. Now we can talk about intents. Yeah, intents. So let's historically. So historically, we sent the user to the exchange, and it became complex because you have different exchange on different chains, and price discovery is a thing, and the user doesn't know where does he get the best price. Next thing we did is, well, we sent the user to an aggregator, first to 1inch, later to someone like Jumper Exchange, because we get you the aggregation of the aggregators. With Jumper Exchange, you get 1inch, 0x, PowerSwap, tons of DEXs. You also get the bridges, so you don't have to think at all anymore. But it doesn't scale, as we have learned, right? All I told you about is all that mess we're in. Our company with 60 people, and as I told you, I could double the company, and still we would be too busy. The model doesn't scale. So what are we going to do? Well, why don't we build not just one aggregator, but lots of specialized ones so we can distribute the work? So now we're sending users to marketplaces, and these marketplaces collect lots of aggregators, solvers. Solvers are mostly aggregators, right? And they can solve for these different things. But it's complicated because you have a chicken egg problem. A marketplace, essentially, always comes with the question, who comes first? Example, Amazon. Amazon in the beginning wanted to be a marketplace for books. It needed the merchants and it needed the consumers. It went to the merchants, hey, sell your books on my place. And the merchants were like, well, do you have users? No, get your users later. No, we're not interested. So they went to the users, hey, we want to sell you all the books, and we aggregate all the books for you. And they were like, can't see them. Yeah, you need to come at the same time. Right? This is a chicken and egg problem, it's difficult. And the one way to make this happen is essentially to make a one-sided market, a multi-sided market one-sided. A typical way to do this is to proxy one side. So you market yourself as a marketplace, but you just fake the other side until you have enough of the other side. So in Amazon's case, Amazon started selling books themselves on their own marketplace platform until they got enough consumers, and then it became attractive to the merchants. And with intent system, it's the same. The intent system goes to the solver, hey, please implement our API, and the solver's like, well, do you have order flow? And intent is like, probably not. We have seen so many intent systems over the past 2 years, Brink, Essential, whatever, you name it, where it's just tough for them to get the order flow. And then they are going to the business. They go to Robinhood, and they're like, Robinhood, hey, could you implement this maybe? And they're like, well, how good are your prices? How competitive are you? They're like, well, yeah, we are in touch with a few solvers. We're going to launch them soon. So it's difficult. So what we're going to see is lots of intent systems bootstrapping their own solver system, running into the same problem DeFi has right now. So how will this play out? Distribution is king. This is how it will play out. The systems that will win are those that already have the distribution. It's 1inch with 1inch Fusion. It's Uniswap with UniX. It's maybe us. We have a decent amount of distribution, but we are not building an intent system yet. We think it's a bit too early. But distribution is king, and we're going to see this play out here very strongly. But it will introduce a bunch of problems for new ecosystems, because now ecosystems need to be implemented by solvers, and these solvers are going to be completely overwhelmed. They have no interest in implementing a solver system that is an ecosystem that doesn't have volume yet. So again, a chicken egg problem between solver and ecosystem. So this problem bubbles up because the solver market is highly competitive on fees. It's low margin because it's all auctions, right? UniX is auctionizing that intent across these solvers. So it's really hard to make money here. On top of that, it's not a venture case. And because it's not a venture case, the solver system cannot take risks. It's not interested in implementing Mode or Mantle yet. Maybe if they believe in the hype, but that's like not based on data. That's like based on faith. And that's not a good business strategy. You do that once or twice, but there are a bunch of L2s that won't see adoption because of that scenario. And we might see a mode via specialization. But again, specialization means chicken egg. Because let's say I'm a solver, I'm saying like, I'm going to focus on perp trading. And instead of aggregating DEXs, I'm going to aggregate GMX. for example, and other solutions, right? Then it also means they need an intent system that brings them intent in the first place, supporting this kind of thing. And so can they actually specialize? Difficult. Then you might argue, well, we're going to have someone that focuses on new upcoming L2s and skips trying to compete with existing established L2s. We see this strategy with Connex right now. Connex is a very established bridge, and they have had a hard time shipping, so they got crushed by bridges like Stargate and so on, even though they have been doing an amazing job. It's an amazing team. But at the same time now, they need to find a different strategy. What they are doing now is essentially focusing on new and upcoming L2s. Smart. Will it play out well? We don't know. 30 ecosystems that do not enough volume. Will that be enough for another financing round? We will see. On the intent side, chicken and egg. Highly competitive for distribution. 1inch, Uniswap, all of that. M1 swimming at the top of distribution. Bloodbath. Fucking bloodbath. It's like we see that now. We are in the same deal flow with 1inch and Uniswap. And I'm just sharing here a little bit, right? Like it is incredibly tough to win deals, and there are incentives being thrown around across different personas and champions across the deal flow. It's incredibly tough. You have to be very, very aggressive. They require market efficiency to be competitive. So if Uniswap manages to ship faster and actually win more solvers fast enough, they're going to be much more competitive than the 1inch Fusion, for example. And yeah, there's a lot of stuff to talk about. I'm out of time, unfortunately. I think one potential mode is exclusive solving. So they get solvers that are very, very good and exclusively solve for them. That again, chicken and egg requires distribution. Otherwise, the solver is not interested. And then, specialization, modularity can be another one. Socket used to be an aggregator, or still is. I don't know. They do a lot. But they trying to be a modular system. But yeah, it's difficult, and chicken and egg across the board. So we will see how that plays out. That's us. What are we? Hard to say. We're all of that. It's all the DeFi liquidity out of one API is the simplest one, I guess. Thanks. If you want to talk about any of this, feel free to ping me. We are talking to so many solutions every week. Have a very good overview. And thanks for coming to the last talk. Any questions? All right. Cool. Enjoy DappCon, the rest of it, SafeCon, and whatever you have planned.